Right, that should be recording. Right, okay, well, thank you all for coming and welcome this morning. We've had a really good number of people sign up for today, so which is excellent news. We're going to run it kind of with people generally muted, and then things like questions in the chat after each speaker, just to try and help manage things. I haven't looked at how many people are on there at the minute, but I think it's around at least 50 anyway, which is really good to see. And I think a few others will keep joining in the background. I'm recording it at the moment, so just so you're aware, and also it'll be available for others coming along afterwards. Yes, otherwise, I'll give you a bit of a background, an update on what's been going on. So as a slight change to schedule, I'm going to present to you on this. Lawrence is currently in an airplane, I understand, I think, or on his way to Portugal somewhere for work, I've been told. So I'm going to give an update on this, and yeah, and we'll go from there. So so if you've got any questions or anything as we go along, put them in the chat, and we'll try and answer those after each bit, and then we'll go on from there. And if there are some questions missed, perhaps we can always try and get to them at the end, and go through those. So as a bit of a background, some of the things that have been done and achieved through the Devon Cornwall Soils Alliance, which has kind of been going for over 2 years now. We've got over 250 members who've signed up over the time, and that's still kind of a growing list, really, and we need to kind of keep that going. I'll kind of add now that you know, although we're moving towards the end of the funded part of the project through the WEG, we very much want Devon Cornwall Soils Alliance to continue as an entity. So that's very much the drive, and we have been given a small extension, which you've just heard about, for another 6 months or so until September, which will help in the kind of short term and get a few extra things done. But we very much want this work to continue, and kind of as an alliance and as a voice. So we've had a series of events and training days. So we had, in particular, a soil mentor training day near the start of the project, and a lot of that was about trying to get sort of alignment and a kind of a shared level of advice and things. So it's kind of like ensuring we were all kind of given the same messages about soil advice. So that was an important one to have. One of the kind of key outputs to try and get those mentors working together. And then we had a series of other events. So we had some sort of more specialist ones around different sort of soil types and landscapes. So we had an uplands event, and we were looking at some of the kind of peatland soils and moorland edge soils around there, which is useful. That was on Bombing Moor, and talking about some of the kind of the common issues there around sort of poaching, mainly sort of livestock impacts, and obviously quite a lot of wet ground up there as well. Then we also had an event on the Colne, so looking at kind of the glaze soils and how they can be managed and things, and some of the difficulties, often, you know, perhaps lying slower to warm up, and also you know, a limited number of days that the soils are workable, relying wet a lot of the time, and issues with drainage, things like that. And then also in East Devon, which I think was looking at more kind of the management of the light sand soils as they get in the area, and some of the issues with holding on to nutrients and soil stability, and kind of lower organic content as well. There's also, we had a couple of very good soil types training events at Langford last September, which was really interesting. So we met at Langford, which was kind of the south and eastern side of Dartmoor, and looked at some of the long-term soil pits they've got there, and discussed some of the soil series and types there and how they formed. And then we kind of followed a soil trail up kind of Dartmoor, moving up all the way up to sort of Princetown, moving higher in elevation, and sort of further west and north, and it's got the weather's getting wetter and wetter. and how that influences the soil types that are found there and how they form over time. So that was really good, looking at how why we get certain soils in certain places, looking at the geology, climate. And so once by the time we got to Princetown, which received a lot of rainfall up there, we're getting into those deeper peat soils. So that was a really good one. We have the kind of the annual conferences at Roadford. Obviously, we struggled the last couple of years with COVID and everything going on. And when we were looking at this, we were thinking about having it online or at Roadford. But a couple of months ago, there were some real concerns about Omicron. And if I'm going to get a bit croaky, I'm just getting over COVID myself. So probably fortuitous for me that it was online. And then also, again, we've had a couple of online conferences held on last May as well. But we've got sort of some future plans planned, and we want to do those. So we've hopefully got a sort of a soil carbon practical event in the kind of late spring, April, May sort of time. And again, we can hopefully go and do some sort of more practical assessments and talk about how we can look at soil carbon and assess it there. So we'll do those, but then we'll also be looking for other events and training opportunities going forward. So if anyone does have any particular good ideas, or as much we feel there's a desire for certain kind of training events or types, do let us know, and that'd be much appreciated. So another part of the project was these kind of feasibility studies, and we're looking at 7 main catchments. So these included the Blackton Brook on Dartmoor, the Caldworthy on the Tamar, the Colebrook in kind of mid Devon, Knollwater in North Devon, the Lower Cobra and Lower Fowl right down in West Cornwall, and also the Neat as well in North Cornwall. And through these, we've got kind of a business case, a slightly more detailed business case, really trying to look at what needs to happen to bring about Water Framework Directive compliance. And we've also got some sort of summary document versions available as well, which we should be able to make available quite soon. They're kind of in the kind of final draft stage. So there'll be much shorter versions, which people get kind of an idea much more quickly about what's going on. And kind of some of those are kind of starting to lead into some sort of practical works and things being targeted, which is good. And also for the Allen and the Corey SHC catchments, which myself and Jorg are working on, we'll also be doing a business case version, a longer one, and a kind of a summary version as well. But it was very interesting doing these studies, and if we jump onto some things we were finding and looking at, what was interesting with these studies and what we were trying to really pull out was more than just identifying the kind of problems as we would normally do, but we're really trying to work out kind of what issues are there around a lack of farm advice and farm grant. What issues do we think perhaps are due to a lack of enforcement of regulations, and also are there instances of area where you've got perhaps a high risk crop in a higher risk area? So if you've got a kind of a steep sloping field, high up the catchment, high rainfall, and it's got some high risk crops, that's probably just not kind of sustainable. And does there need to be kind of a bit of a land use change to some degree? So there were some very interesting conversations around that, and then we were trying to develop these feasibility studies. And then also there's quite a challenge on how you try and encapsulate that and compare between catchments. It gets quite difficult, can be quite subjective. So we tried to get some of these kind of categories, and we added in this kind of bit of a survey afterwards to try and look at what can be done. And some of the things that kind of came out was we tried to pick out what are the issues we saw would be considered a compliance failure, for example, predominantly that around things like foreign rules to water and soil loss. And also, would in these instances better enforcement of those regulations, enforcement or advice, awareness, help make a difference as well. And the feedback is that most of that would, so that was one of the kind of key takeaway elements in that. But then also there was also the need for farm grants, farm advice, and what was going on, and also the catchments were different. So some were very much, it would have been more light touch, a bit of extra advice and grant work, a couple of issues picked out. We probably reached compliance. Some other catchments, much bigger issues, bigger scale, more complicated. You're probably not going to get a change in WFD status about some big things changing or bigger things. So that was useful and interesting exercise, and trying to get that.
Sorry, Giles. Sorry, Giles.
Yeah.
Have you got any slides on this at the moment?
Yeah. Oh yeah, is it not sharing? Sorry, yeah.
No. I thought you knew that. I thought you were doing an informal start. Apologies.
Yeah, no, sorry. Yeah. What am I saying? Try that.
Perfect.
Is that better?
Yeah.
That's what you missed. There you go. Sorry. So that gives you an idea there of the different things we were finding and seeing. So there's kind of variations in sort of cost, expected cost, and price, and also variations in what would be required to bring about those changes. Kind of an additional piece of work was also the micro catchments, which we were looking at. So there were a series of micro catchments identified, these are small catchments below 10 kilometres squared, where there's issues of sort of localised flooding and potential impacts on WFD. So perhaps they have a WFD failure. And it's really a mapping and modelling exercise to pick out some of those catchments and then go through those and prioritise them. So we've now gone through a batch of those and picked out 10 sort of highlighted micro catchments which we're looking at. Oh, thanks, George. And so we're looking through those and picking up those, so they'll be delivered in the next couple of months, basically. And a colleague agent will be going out to site and looking at some of those, investigating them, trying to see what kind of current land use is there, and if that's affecting the kind of the status of WFD.
Giles, so your presentation stopped again.
Oh yes, okay, yeah. Press on again. Share.
Stop sharing.
Back again?
Yeah, back up again.
Yeah. Okay. And then the final part, also that we've been doing some more work on, is the soil organic carbon testing. Which is also funded for the project. So it's helped us kind of upscale some of our kind of lab kit required to try and undertake that work, and basically increase the ability to deliver soil carbon assessments across the area. This is mainly about trying to sort of start or establish a bit of a baseline, so we can go back to some of those areas in the future. And some of those assessments will be available in the across the catchment, and we've done some also in the SAC catchments as well. So again, it's kind of a growing area, and there'll be quite a few of these delivered through the project and through other projects, kind of making it available as a resource. So that gives you most of the outputs on that, really. I don't know if there's any particular questions anyone has or in the chat. Otherwise, we'll start setting up for Becky. But
nothing has come through just yet, but
okay,
can still fly in, and we'll pick them up at any time. But yeah, Becky, if you want to set yourself up.
That's great. I'll unshare mine. Is yours coming up, Becky? I'm not had it coming through.
Yours is still up at the moment for me.
Oh, okay.
Ah.
Are you sharing yours, Jog?
Yeah, it's not. No, it's I got nothing of. I've just got the normal group look. So
Okay. I can always load it in the background if it's not going to come through.
We definitely shared. Ah, here we go. Here we go.
Yeah.
Perfect.
Yep. Can you see that? Okay.
Yeah, I can.
Yeah, that's the red yogurt one. Yeah, great. So yeah, if you're ready, Becky, I'll just a quick background, Becky. So
hang on, Becky, before you start, I got Annabelle saying she can see my presentation somehow.
That's what I could see. I could see your presentation too.
Oh, I don't know why. I'll quit out and then I'll come back in.
Yeah, I think that's best.
Can you all see my presentation?
Yeah. So thanks, Becky. So yes, Becky is the business development and technical director at the Farm Carbon Toolkit, and she's been working with the Farm Carbon Toolkit since 2013, and working between that and Dutchy College. So more recently, she's been running the soil carbon project, working with farmers to measure, monitor and manage soil carbon for the last 6 years, as well as working with a range of farmers and businesses on reducing greenhouse emissions and improving soil health and carbon sequestration. So I'll hand over to you, Becky, if that's right, and make a start.
Perfect. All right. Well, thank you ever so much, Giles. And yeah, it's really lovely to be with you here this morning. Giles asked me to come along and talk and gave me the sort of title of what farmers can do to raise soil carbon levels. I'm sure we've got lots of very exciting presentations coming along after me that's going to dig deep into some of the issues around this. So my presentation this morning is very much from a practical perspective in terms of some of the things that we can do, and it will be, I suppose, using some of the data and resources that we've been generating through the Soil Carbon Project and continuing to work on through the Farm Net Zero project, and I'll explain a little bit more about those as we go along. And yes, sort of following that introduction, for anybody that doesn't know me or us, so yeah, I work at the Farm Carbon Toolkit. We're a farmer-led organisation, really aimed at trying to provide practical tools and resources for farmers around reducing greenhouse gas emissions, improving energy resilience, and with a particular focus on soil health and what that does in terms of, creating business resilience for our farmers. So as I say, we've been around since 2008, really talking about carbon, greenhouse gas emissions and soil health and that sort of thing. So in terms of what we do, the two main resources of the organisation are a carbon calculator, which allows farmers to calculate their current carbon balance, gives them a number, but also then feeds through into a toolkit. So you can sort of start to say, well, is that good? Is that bad? What might I be able to do in terms of actually changing that? And the toolkit really starts to include a lot of those practical things that you can do to reduce emissions and improve soil health. We also run a range of applied research projects. So as Giles said earlier, and I'll talk a little bit more as we go through, our soil carbon project run in partnership with Dutchy College, with Rothamsted Research North Wick, and with the University of Plymouth, as well, with a partnership of a lot of fantastic farmers with a particular concentration down here in the southwest, but also running all across the UK. And so that project is, I'll say, within the southwest, funded through Agritech has finished, but we're continuing some of that national sampling, and the sampling that's been happening in Cornwall is continuing through our Farm Net Zero project, which again I'll talk about in a little while. But more widely than that, we spend a lot of time doing soil sampling and carbon testing, both for individual farming businesses across national parks, through supply chains, with local authorities, really just trying to understand what's possible and what's happening in terms of understanding baseline carbon and organic matter levels, but also how that links into soil health and where the change might be possible. And a key part of what we do is really trying to create networks and share knowledge, because a lot of this sort of thing, actually farmers talking to farmers is the best way to make change happen. And so that's really what we try and advocate in terms of helping share information, share knowledge. So it's great to be able to be here this morning and hear some of the great stuff that's been happening through the Alliance. We also run the Soil Farmer of the Year competition, aiming to champion and promote those farmers who are doing fantastic things around sustainable soils management. That competition opens each year on World Soils Day, and it's just closed this year. So we're just going through and scrutinising the applications at the moment before we announce the finalists and then the eventual winners, which will happen later on this year. And then we also have a range of strategic projects. So we have the Farm Net Zero project, which I'll talk a little bit more about in a minute. And then we also work with the Duchy of Cornwall and others to help understand what's happening across their land. So soil then, and again, you know, the fact that all of you guys are here this morning, you know, is you know, I don't need to explain to you about the importance of soil. You know, it's something which obviously connects all of us together, but also is so fundamentally important for everything that we're doing on farm, but also some of those wider bits around water cycling, nutrient cycling, climate change solutions, all these other sort of things. But if we focus for a minute on the importance of soil carbon and how soil carbon fits into that wider picture around soil health. And you know, if we think about those three sides of soil health in terms of making sure that we're managing our soil physical health, in terms of making sure, as Giles was saying at the beginning, we've got a good amount, we've got good structure there, we've got good amounts of air and water within our soils. It's able to hold what it needs to in terms of water. It's able to have enough air to allow our microbes to breathe. It's in the, you know, all of those sort of things. Soil carbon is fundamentally important to what's happening in terms of our soil physical health. If we think about our chemical health in terms of the balance of our nutrients, whether our soils are in the right pH, all those other things, again, soil carbon is a fundamentally important part of that in terms of providing some of those sites which allow those nutrients to bind to, but also in terms of buffering and balancing the system. And we think about it from a biological perspective in terms of the fact that our soils are alive. Well, obviously the carbon is that fuel that feeds the system in terms of all of those fantastic things that our biology are doing within our soils. So carbon is really important from a soil health perspective, as well as part of that sort of climate change solution perspective as well. And obviously, this is what we've been looking at through our soil carbon project, really starting to understand, we know it's important. You know, we know that it's important both from an individual farming business perspective, but also from that sort of wider perspective. But actually, what can we do in terms of changing our soil carbon amounts and our soil organic matter amounts? What are those things that we can do? Starting off with understanding, how do we test for it? And I know that's something that we're going to be focusing on when we do our event later on in the field. But actually, what are the different ways that we can measure it? Is it about soil organic matter? Is it about soil organic carbon? You know, when do we need to sample? How many samples do we need to take? Can we link any of those with what's happening in the field? So really starting to understand that measurement piece. But almost more importantly, also then being able to understand, so what are those management practices that we can do, and what are the impact that they will have on our soil carbon levels, and more widely in terms of what are those wider impacts on how our farms are managed, both from a water perspective, from a nutrient perspective, and from a profitability perspective. And also starting to think about any of those sort of soil health measures. So can we link any of those into what's happening in terms of those improved soil carbon content? So starting to understand how we measure it, how we monitor it, and then more importantly, what can we do in terms of managing it, and how does that link back around, not just to how our farm is performing from a profitability perspective, but also more widely in terms of the sort of greenhouse gas emissions. What are the things that are going to help on that side as well? And one of the things that obviously we've produced, and again, you know, we have lots of copies of it in hard copy. So if anybody would like some to, you know, distribute around their farmers, please do let me know and I can post you some out. But we also have it as a PDF on our website. So one of the outputs of the Soil Carbon Project is this field guide. So really, if you're interested in how you test and the different methodologies, then I would really signpost you to that guide, really understanding. And it's a synthesis of the methodology work that's come from that Soil Carbon Project. And again, that's the sort of partnership project, so work done from Duchy College, from Farm Carbon Toolkit, from Rothamsted Research, and from the University of Plymouth. And we know that this is a really fast moving area, but obviously this is a synthesis of the knowledge that we have at the moment. So what are the options then that we've got in terms of building soil carbon? And, you know, if we've got this opportunity to start to not just improve how our individual farm is performing, but also some of those wider issues in terms of generating that climate solution, what can we do? And what are those options? And if we look traditionally in terms of those accounting methods that we use for being able to account for soil carbon within those sort of carbon metrics, the way that we traditionally account for it is if we change our land use. So if we have an arable field and we put that arable field through an arable reversion or something like that, and we turn that into a grassland field, that change of land use from arable to grassland is afforded an improvement in the soil carbon levels of that field. Similarly, if we have a grassland field and we then transition that over to a woodland, that change of land use from grassland to woodland, again, is afforded an improvement in soil carbon when we think about that accounting methodology. But that's a pretty dramatic change. And again, that's potentially not something that we can do every year. Actually, that's just the change from one to another. And again, it's the change in terms of disturbance, cultivation, all those things which are actually leading to that change to be able to be accounted for. But what are the things that we can do within those broad sort of categories of land use type? And what impact do they have? Well, again, we can think about some of these sort of broad sweeping statements or these big picture things. So reduce erosion. If our soil is leaving the field, then that's taking with it, as you all know, a lot of stuff that actually is important to keep in the field. Not only next year's growing media, but it's also taking carbon, it's potentially taking nutrients and everything else. So actually, if we can keep the soil in the field, where we can use it to grow the crops or the grass, then that's fantastic. So stop the amount of carbon that's leaving the system. We can also start to think about how we feed more carbon into the system. So how are we using some of those organic amendments? So optimizing our strategies for using manure, for using other bits and pieces that we might be able to, that is putting more carbon into that system. We can also start to think about reducing the disturbance of our soil. Obviously, when we cultivate or we till our soil, that sudden flush of oxygen that comes in, it stimulates those soil microbes which start to respire. And obviously, a byproduct of that respiration is carbon, which goes back up into the atmosphere. So again, if we can start to think about reducing that cultivation, then actually that reduces that disturbance. And so that carbon will stay there. But again, that's quite a big area to think about. And actually, by how much? And then we can also start to think about more deeper roots in deeper soil horizons. So starting to think about our soil, not just as a sort of 2D thing, but actually start to think about it in 3D. So how can we actually start to understand not just how much carbon is in our soil, but actually where is it? And actually, can we start to farm slightly deeper? Can we start to get those rooting and those microbial activities happening further down our soil profile, so we can actually start to move some of that more active cycling carbon down into more long-term stable carbon? So these are some of the sort of, you know, big things that we can start to think about. But again, they're quite big sweeping statements. And we also need to think about the fact that each farm is unique. And obviously, this is a graphic that's come from the NFU in terms of achieving net zero by 2040. But we need to remember that we're not just looking at soil carbon in isolation. We're looking at carbon as part of that driving force to fuel those soil properties and those soil characteristics that are happening within our soil. So again, we can't start to look at these things in isolation. We need to understand actually how these gases are flowing through our system, and what the opportunities are to start to provide those positive benefits around improved and enhanced soil carbon storage, but also how that might also help in terms of mitigating some of those other greenhouse gas emissions that we might be thinking about. But it's also worth remembering that there aren't these sort of simple solutions that are going to work everywhere. Giles spoke about at the beginning about the, the different types of soil that we have across the catchments, the different types of management practice. So that's really where a sort of partnership approach and understanding what those strategic priorities are for the individual farmers, and actually how those might build up together across catchments, and how this can really start to provide a way to understand where their soils currently are and what the opportunities are to improve them. So we've got these big picture things, and we've got these complex biological systems, which means that it can be quite a complicated thing to think about for farmers. We know that actually not only do we need to protect the carbon that we've already got, so it's not always just about increasing, it's actually about looking after and maintaining those existing carbon stocks that we have across our landscapes. And we know that actually there are a variety of methods that we can use, and that we should be protecting or enhancing that because of that really fundamental and wider role in terms of maintaining soil quality and enhancing crop production. But we still need to get to a little bit more of the detail in terms of, well, what do we need to do? And what are those practices that we know will make a difference? And not just those sort of large, those bigger picture practices, but actually getting quite down into the nitty gritty in terms of, well, okay, we're going to reduce tillage. Actually, does it have to be no-till? Or can it be min-till? Where does strip-till fit into this? If we're thinking about enhanced diversity within our grasslands, actually, how many species do we need? Is there some key species that actually are really important in terms of enhancing those landscape and soil functions? If we want to try and follow that practice in terms of keeping our soil covered, what's the magic formula in terms of cover crops or catch crops, or actually with undersowing to try and stabilize that soil? And again, thinking about the use of manures or digestates or some of those other materials that we might be using. So we need a little bit more detail in terms of understanding where you are to start off with in terms of that baseline, and then what the most important thing might be for your farm or for your system to actually improve. And this is where we really need that evidence. So again, starting to delve down and dig a little bit deeper in terms of what works. And also starting to not just, as I say, not just think about soil carbon in isolation, but start to think about how soil carbon fits with those wider farm objectives. And again, I know it can be slightly, it's something that everybody's thinking about at the moment. There's lots of conversations about, the potential business opportunities from carbon and all those other sort of things. But how fundamentally it comes down to how does improving my soil actually fit with what I'm trying to do on my farm anyway? And then starting to think about what the opportunities are for your soil type, for your rotation and for your system. And then starting to think about what impact will it have. And then we get to the bit in terms of actually, how do I go about doing it? So in terms of where we are now and some current results that we've got based on the back of the sort of soil carbon project, but also how we're using those to really feed into some more work that we're doing within the Farm Net Zero projects. So some sort of, I suppose, bigger picture outcomes from the soil carbon project, I suppose. There are some real positives here. We know that we can measure soil carbon, so that's great, because it can be complicated. There are there are lots of different ways that you can do it, and it depends on whether you're measuring organic matter, organic carbon, or all those other sort of things. But we can measure it, so that's good. More excitingly, I suppose, farmers can build soil carbon. So that's great. Now, we're not saying that everybody can build it by the same amount everywhere, but there is potential to do that. And again, we can see that both within the modelling data that's come in that in the sort of net zero models that have been done. But there is an opportunity to do that. We can provide that climate solution. But the really important bit, and I suppose the really tricky bit, is that it's not just as simple as saying everybody goes and does this practice and it will solve the problem. How you manage your land has an impact. And that's where we get a little bit complicated, because actually, again, there are all those different variables and everything that comes into that management that are starting to be unpicked. But it's also important, as I said earlier, to remember that actually it's that whole farm footprint we're looking at, and not just looking at soils in isolation, and really starting to focus on those practices that will help both from a reduction in emissions perspective and also look at improving carbon sequestration and protecting that existing carbon stock. And if you look at what's happening in terms of input prices, all that sort of thing, anything that we can do to reduce emissions makes good business sense, as well as helping with reducing our greenhouse gas emissions and allowing us to make the best use of what's happening in terms of carbon sequestration. So what have we found so far? Well, we found some really interesting results. And again, we're still starting to unpick those to actually start to get some sort of definitive conclusions. But we found that across the thousands and thousands of samples that we've taken over the last sort of 5-6 years, there is an impact in terms of time since cultivation. So we can see there's a really good relationship between years since ploughing and actually carbon content. But, you know, if we think back to what I showed a few slides ago, that was there. We know that actually, you know, that change in land use from one to the other, a big proportion of that is that you've got a perennial crop growing and also you've got a lower of disturbance. So we know that. But actually starting to unpick that in a little bit more detail and start to look at those farms and those situations where they're starting to use, you know, more minimal tillage, more direct drilling type approaches, but also really importantly for us down here, how do they work within our rotations and our systems? We've started to find some really interesting work, some really interesting results around grazing systems. So again, starting to look at that sort of move away from, you know, more set stock to more rotational grazing systems. Not only do we find that that does help in terms of pasture utilization, but there does seem to be an impact in terms of enhanced soil carbon sequestration. But again, we're starting to unpick that in terms of understanding those definitive links. Looking at diverse rotations, again, something that we're very good at down here a lot of the time, but really starting to look, that has an impact as well. And then thinking about cultivation system. So these are some of the things that we're now starting to look at in a bit more detail on farms. So working with our absolutely fantastic farmers that we work with within the Soil Carbon Project and within the Farm Net Zero Project, because actually this is actually, you know, we are doing this work and looking at what's happening within real farming businesses. And that's where we really have to start looking at this sort of thing. Other really important things that we found is obviously the impact of testing depth. So starting to look at not just how much carbon is there, but actually where is it within your soil profile? And can you start to try and, as I say, get that carbon to move more deeply? And also the really important relationship with clay content. So the amount of carbon is inherently bound up with how much clay you have in your soil. But also thinking back to, you know, making those different management decisions. How can we also link that with those soil health indicators? So what are those things that we can actually go out and look at that actually will show an impact and will show that relationship with carbon, but doesn't need to involve, you know, faffing around with lab analysis? And as we've said, you know, we found there's a really good relationship between aggregate stability or the slate test and carbon content. So again, that can be a really useful thing that you can do just to sort of look and do some comparison across your fields. And also starting to ground truth your results. So if you've been part of the baselining that Giles spoke about at the beginning, actually going, not just relying on your lab analysis, but actually getting your spade, going out and having a look at whether the results that you're getting in terms of carbon, whether you can see some of those benefits in terms of those soil health indicators at the same time. So I also just wanted to talk a little bit about what we're doing in our Farm Net Zero project. And our Farm Net Zero project has followed on from our soil carbon project down here in Cornwall. We're working across 3 regions of Cornwall, and we're really lucky to be able to have this project, which is going for 5 years, really starting to showcase the potential that farmers have to contribute to those net zero aspirations, not just for their own farm, but really starting to cement the opportunities that they have within their communities and then starting to communicate that more widely afield. So we have 40 monitor farms that are some of them are a continuation of the farms that we've had within the Soil Carbon Project, and then we have some new farms coming on as well. And those monitor farms are being having testing done, both from a soil perspective, but also from a carbon footprint perspective. But then we also have set up 3 demonstration farms, and the real aim for those demonstration farms and the challenge for them is to get them to net zero by 2025 and use them as sort of living farm labs where we can start to understand what the drivers are, what the challenges and the barriers are, and set up trials and understand how we can get there. Now, Farm Net Zero, we run in a partnership with West Country Rivers Trust, with Duchy College, with Innovation for Agriculture, and also with Innovative Farmers. So it's a partnership project, I say, running within Cornwall. And I just thought I'd show you, you know, what we're doing currently with our demo farms and some of the trials that we've got that are happening, so that we can start to dig into this in a little bit more detail. So one of our 3 demonstration farms, one of which is Blable Farm, which is a beef and arable farm. They're really interested and really focused on optimizing forage yield and looking to try and track that through in terms of into meat quality. But we've got a range of trials that are set up on their farm. We've got looking at the importance of diverse grass mixes and actually utilizing a paddock grazing system. So we've got some comparative trials down there. There's been an overwinter this last winter, an overwinter cover crop trial, which we've got on this farm, and we've got on a couple of the monitor farms as well, looking at the differences in terms of soil characteristics, but also looking at forage quality, different mixes that have gone in. And also these guys are looking at doing some work on bedding on green waste compost. So looking at both the nutritive value of the material that comes out of the shed, but also what benefit does that have in terms of building soil organic matter. So that's one of our demonstration farms. We've got another one, Earth Barton, which is quite near to Saltash, and again has taken on some ground which has been a very conventional farm growing bulbs, veg and arable, and is now moving through a transition to a sort of farm with a real focus on soil health and building organic matter. And again, over there, we've got a range of different trials looking at different diverse lays. And also Tim is really keen on making climate compost and looking at the opportunities within compost and different inoculations and other bits and pieces to really start to provide something which is useful for our soil biology. And then our final farm, which is a dairy farm, really starting to look at a range of different, so we've got a range of different trials going on down there. One looking at obviously not just the below ground benefits of those diverse swards, but also looking at the impact on cow behaviour, both in terms of rumination and also their daily activity. Starting to look at integration of field veg into a more grass-based dominated rotation. So again, looking at the potential drawbacks or benefits of those sort of systems. Again, looking at wood chip bedding and what happens in terms of the benefits back into the field when that is put back up. Looking at overwintering grazing again, and then again looking at the difference in soil health and carbon from herbal lays compared to that sort of more ryegrass white clover. So there's a lot of trials that are actually happening at the moment. There's loads more data on our website, all the fact sheets and the results of some of those initial trials, but these are continuing to be updated. And again, if any of you are based in Cornwall, please do get involved with the project, because again, it's really been set up to try and see what's possible. And so it's really important to get as many people involved as possible. So just to finish off when really, it's been a little bit of a gallop through, but we know that soil carbon has benefits in terms of that improving soil health and building that business resilience. So again, there's a huge amount of attention at the moment, obviously on soil carbon from its climate credentials, but actually coming right back down to the individual farm business level. If we can do that, we will improve our resilience of our system. And with everything else going on at the moment, that really makes good business sense. There's loads to potentially measure. Okay, again, depending on what system and all those other sort of things, but actually, and it can seem really, really overwhelming. But just start by focusing on what information and what data will help you make better management decisions. Okay, because you're never going to regret that. Because actually that then gives you that tools and knowledge to be able to understand what can you difference, where are you starting from, and actually what are your options for moving forward. Again, baselining soil carbon for the future, all this sort of stuff is really being focused on. But don't forget your spade. You can see so much with that. And then just finally, really, I really would encourage you to get involved if you're not already with the Farm Net Zero project. That means that you can keep up to date with the results as they come through. And again, we can start to put more detail onto the bottom of all of these things and really provide that information that helps farmers make better management decisions. And I think that's it. Perfect. So, yeah, if that's all right, Giles. my email address is there if anybody wants to get in contact.
Great, that's great, Becky. Thanks for that. Really good to see that and some of those kind of practical elements and what's going on locally. There's a couple of questions in the chat. Some of them may have been covered a bit, but there's a little bit here about Charlotte's got about. So thanks, Becky. Very interesting. Are you tracking how many implement those types of recommendations and what the range of decision drivers are?
Yes, we are.
Yeah.
So each of the fields that we've got included in the project, we've got really detailed management information in terms of everything that's gone on, all the inputs that have gone on and come off that field for the last 5 years. We've got previous cropping, we've got really detailed information. And then as we move forward, obviously those management practices that are being changed, we've got that information so that we can start to understand. It's really complicated to unpick because there are so many different things, but that's why we've tried to collect as much information as possible so we can start to sort of pull out what the impact of some of those management practices are. I mean, there's always going to be big error bars, there's always going to be a little bit of uncertainty, but if we can move slightly more in the direction, then actually that gives people, and that was the whole point of the soil carbon project, was to give people confidence in terms of what some of the things are that they could do. So yeah, we are tracking all of that, and through the ones that are continuing to be monitored, both within the Farm Net Zero project, but also more widely in our national soil carbon project, which is continuing. We can continue to keep revisiting those people who have made changes and actually the impact of those coming through, so that we've got those sort of, I suppose, full case studies from start to finish. But we did some research and some a big farmer survey a couple of years ago, just asking in terms of what were the barriers in terms of stopping farmers actually making changes. And the biggest thing that came back was, I don't know what action to take. And so actually bringing it back to an individual farming level and understanding where they're starting from and then what the options are for them moving forward is a key part of that, which was really tries to inform where we're moving to.
Okay, great, thank you. Got a question from John Morgan. So he's just talking about the grazing systems and whether you thought if there was a grazing system which tended to lead to an increase in soil carbon over time.
So we are, we're certainly starting to see that as I say, that move from set stock to rotational is having an impact. So we've got some fields where that, we've got some trials where that's having an impact. It depends on where you're starting from. And if you link into that some of the work that's been done through other agri-tech projects in terms of the sort of cell grazing type models, that seems to be having an impact as well. There's still a lot more to unpick, but certainly, moving to those sort of systems where you are, you've got that period of rest, that period of animal impact, and then that period of rest does seem to be having an impact. Will it work everywhere to the same level? Probably not. But again, there does seem to, and again, at the same time, you'll also get that enhanced forage utilization. As I say, the challenge is understanding where you're starting from and actually seeing how it also aligns with that, as I say, improved forage utilization as well. But we have got, we've got farms where they've made that change, and we've got really good data in terms of showing that. But again, it's always pulling it out from all of the statistics, which can be the challenge where you've got multiple, because we're doing it at a farm level rather than complete replicated trials. But again, within the Farm Net Zero demo farms, we've got some we've got some more replicated plot trials, so we'll be able to look at the impact of those at all the different depths at the same time. So we should have some good stuff that's coming out of that.
Great, and there's a question from Tom, just looking at, have you looked at the impacts of drainage on soil organic carbon?
It's something that we were looking at the start. We don't do anything. It's not one of the things that we include routinely, but it's important to have it in there. So we'd be really interested in terms of looking at that potentially across our Farm Net Zero farms, and how we can start to take account of what's happening in terms of whether they are drained or where that where the water is sitting and all those sort of things, because it will have a big impact.
Great. What else have we got? That's pretty much it. I mean, there's a comment here about any news on the National Soil Health Plan. but I'm not so aware of that.
I'm not either, unfortunately.
That's fine. We can always come back to that later if we got an answer. Okay, well, that's great. Well, I'll load up. Tim's gonna present next, and I'm gonna load up the talk for him. So I shall give that a go and see if I can get that to share. So I'll share screen, and then I'll pass over to Tim in a minute. So let me know when this is working. Is that coming up now?
Yeah.
Yeah.
Great. Okay. Well, I'll give Tim a quick intro if you're ready, Tim.
Yes.
Great. Okay. Yeah. So Tim grew up on the South Lincolnshire fens, or on the edge, and cut his teeth in agriculture, working on a small farm locally during the school holidays, and completed research for his geomorphology PhD in 1965, and then looked to join the Soil Survey of England and Wales, and what he thought perhaps was kind of a short-term thing, and it ended up being 36 years, and he worked mainly in the southwest, and also some other national and international areas as well. Since retiring, he's also undertaken some very detailed surveys of northeast Dartmoor, which have been published through sponsorship funding. So that gives you a bit of background on Tim, and I'll hand over to him if you're okay, and then if you just say when you're on the next slide, I'll move it along.
Yeah. Okay, Giles. Thank you. Well, the main point of what I want to say is to give an idea of the range of circumstances that are likely to be met across the two counties' soils from the detailed surveys that the Soil Survey of England and Wales undertook. And I totting up the amount of time that was spent, it was about 75 man years were spent in the two counties. So if we can have the next slide, Giles. Thinking first of all about soil organic carbon, it's what I should be saying is really, and what I'll be presenting will be a guide. A rough rule of thumb is, of course, that the darker the soil, the larger the soil organic carbon, but it needs some care in interpretation of that. The natural influences on soil organic carbon are acidity, long seasonal wetness, particle size or texture, if you like, clay content, sand content, silt content, and time. Strongly expressed as soil type, but there are also additions and land management affecting it. Now, I think for meaningful comparisons, robust standards are needed, and many of those are around. So avoid reinventing the wheel if possible. The soil survey methods that I'm going to quote are based on loss on ignition, warts and all, by the broad formula that is there on the screen. Largely because there are so many loss on ignition results available. Right, next slide, Giles, please.
Yeah. Oops.
Now this table, remember, is a guide. The red columns represent the mean values for topsoils and subsoils. The top two rows represent the mineral soils, which are the run-of-the-mill agricultural soils, or the end members of those agricultural soils. The bottom rows are more the upland margin soils with more soil organic carbon and larger ranges. And of course, the podsolic soils have this down profile transfer of minerals and humus, which is part of their pedogenesis, part of their soil forming. and consequently tend to have higher subsoil organic carbon. Move on to the next one, just as a demonstration of the sort of profiles we're talking about. These are the end members of the agricultural range. On the left, the brown mineral soil with free drainage, seldom wet. On the right, the surface wet mineral soil with long seasonal waterlogging, shown by its grey mottling in the subsoil. Next slide, please, Giles. Still waiting. Thank you. These are from the upland margins and downlands, wastes, bogs and moors, and land that has been targets for enclosure in relatively recent history, in recent centuries. And the fields on this sort of ground, where they're in agriculture, are more often rectangular, bigger, and have names such as down, which is a bit of a giveaway. Next one, please, Giles. Just trying to show something of the distribution of these different soil types from the national soil map around Dartmoor, with the brown background, brown colour, the more or less freely draining soils as in profile 1, and the dark green, the wet mineral soils out in that strip to the top left-hand corner. And then on the higher ground around Dartmoor, the little strip of pink is the stagnopod soils. The light green on the Dartmoor in the centre it is stagnohumic soils with surface wetness and a larger amount of surface humus, and then groundwater glaze shown by the little strips of blue in the valley bottoms. Next slide, please, Giles.
That come through?
Tim, you're on mute.
Unmuted. Sorry, I don't know how that's happened.
That's all right.
Still nothing through, but I think
we're on the slide now with robust measurements are needed.
Right. Well,
can you not see that yet?
No, I can't. No, but I mean the point really is that if soil organic carbon or carbon measurements are to be used for usable comparisons, then either for payment schemes or for monitoring, then there need to be robust measurements of soil organic carbon, of bulk density of the soil, of horizon thickness, and also of stoniness, which is quite an issue in parts of the southwest. So if we have the next slide, I can't see it, but has it come up?
Yes, should have now.
It's a shallow profile with some comment about earthworms on it.
Yeah, basically your soil horizons and the thicknesses vary. Always dig and look first.
Well, I hope I'm the only one that can't see it, but it's an example of how soil horizons can vary really quite quickly, and it's relevant in this particular case because even if the soil carbon in the two layers that you can see are the same, the effect of the stone dilution is going to affect the stock of carbon, and of course, thickest topsoils, in a more general term, thickest topsoils are most common in conventional tillage, whereas they're often thinner in old permanent pastures or on long established min-till or no-till, and of course in old woodlands. So if we go to the next slide, Giles, it should be bulk density measurement. Yep. Again, I can't see it, but this requires a good deal of care to get reliable results. But the old soil survey way was to use a stabilized sampling tool, a sort of piston with a sampling arrangement, a corer on the bottom, which had a sort of half-meter long shaft with a drop hammer on it. You held this vertically on a prepared flat sort of shelf in a soil pit, drop the hammer, and it gradually eases the corer into the ground. It was important really that you kept this thing as stable as possible, because you very quickly get edge effects if there's any wobble on it, and that is a real risk, particularly in stony soils. And if you haven't got a sophisticated sampler like this, which was invented in East Africa, I think, if you're doing it with more cup-like samplers, there's a great, and if they're small, just a few centimeters across, there's a real risk of introducing quite serious errors into the sample. So it needs doing with a good deal of care, and I would say really it isn't whack-a-mole, if you like. It needs doing carefully. So I think that's all about the bulk density measurement technique. Hopefully we can demonstrate that if we have a field day looking at these things, if I can get hold of one of these samplers. Andy Williams at Plymouth University made one back in the day. I don't know whether it's still there. On to the next slide.
Yeah, we've got detailed soil surveys map.
Right. Well, that shows what was done in the way of detailed soil surveying, and it's the source of the figures on bulk density, stoniness, and loss on ignition soil organic carbon that I quote in the tables. The map really indicates where detailed soil surveys were done before 1979, before the general national soil map was started. The little squares particularly were chosen to sample and represent major soil landscapes, with patterns from them being can be extrapolated across each soil landscape. Each 10 by 10 square took a few man-years of work to do, whereas for the national soil map it was about 10 days in the field for each 10 by 10 kilometres square. The detailed mapping was field by field, and separations down to about a hectare or less, not the 50 hectares square kilometre limit on the national map. Two more detailed maps have been done since then. The one that Giles mentioned that I'd done on northeastern Dartmoor, and another one David Hogan did between Tiverton and Honiton. Okay, next.
Yeah, this is the bulk density slide measurements in Devon.
Right. Well, the the point below that is really to do with that is that the red figures give a guide to the range of values likely to be encountered for bulk density. The topsoils mean of about 1.04 are smaller than the subsoil values, but the overall ranges are quite small. So if you're getting within those ranges, then I think you should be reasonably happy of the bulk density figures that you're getting. If you're outside that range, there's something of a worry of whether you've got it right. On to the next slide, please, Giles.
Yeah, so this is a work example of the Denby series under permanent pasture.
There's an error in the heading of the right-hand column. First of all, it should read soil organic carbon grams per decimeter square for horizon thickness, which should indicate kilograms per 10 meters square or tons per hectare. But concentrating on the red figures in the top row, which is the topsoil, the decimeter is used in the second right-hand column rather than centimeters, as it makes the calculation and final answer a little more straightforward, as kilograms or tons per unit area. The technique is simply to multiply the figures of soil organic carbon by the bulk density, stoniness, and horizon thickness to end up with the topsoils value in the right-hand column. If you repeat the calculations for the subsoil layers, the B horizons below that in black, then that gives the overall profile soil organic carbon in unit areas, which in this particular case, it's quite interesting the amount of subsoil carbon that shows in a freely draining soil. Next slide, please.
Yeah.
Still not getting any pictures, John. So winging it a little bit. But,
yeah, stock across SX68.
Well, what I did in the Dartmoor survey was to use as many of these calculations as I could and summarize them for the 10 by 20 square kilometers of the northeast Dartmoor survey, and in the book I also did it for the Dartmoor National Park. I think an interesting thing that comes out of it is that because of the much lower bulk density of the peat, the stock of peat soil carbon appears unexpectedly small, but you have to bear in mind that the bulk density of fibrous peat, the actively growing peat, is about 1.8, much less than the mineral soil, and even the humified peat, which is perhaps a little degraded, is about 0.3 grams per cubic centimetre. Next slide, anyway.
Shall I try and reshare the screen and see if that helps?
If you can have a go, it would be a help.
I'll do that. I'll try this and see if it comes up again.
Yes, thank you.
Is that there?
No, I think oh, it's gone again.
Oh yeah, sorry. It'll be back. Hang on. There we are.
Yeah,
that's it.
As I've said, stoniness is an issue in the necessary calculations of soil organic carbon. This is a guide to the relative incidence of stones in soil horizons across Devon and Cornwall. It's based on the green map detailed descriptions extracted from 1232 soil horizons, and the most common, as you can see, is the stony category, which is 5 to 20%, making up about almost a third of the horizons described. And you have to bear in mind that at least the Soil Survey Field Handbook says that core sampling becomes unreliable once stones exceed about 10% of the soil volume. And size of stone, of course, is an issue affecting ease of core sampling. So don't expect bulk density sampling to be straightforward every time. And Soil Survey Field Handbook page 99 is worth looking at over this. Well, I think that's probably enough about soils and carbon from what I've extracted, and perhaps we'll go on to the next slide and just about a bit about soil and habitat benchmarking. There's a little quote from Roman, which I think is relevant. But I think I have to say that soils, being a product of interactions of physical, chemical and biological processes plus time, much as Becky has said, these help to define the habitats in the landscape, and humans have made and will make modifications through agriculture and other activities. The soil forming processes vary from place to place, and the soil profiles contain pointers to that evolution. If we can move on again. Those pointers really are weathering forms, glaying, mottling, indicating anaerobic conditions, and most likely protracted waterlogging. Oxidative weathering, the uniform brown colours which signify good aeration and free drainage, and of course the accumulation of organic matter as dark colours, and sometimes intimate organic matter, sometimes with plant structures. There are a range of obvious associated vegetation, community and soil relationships. Some of them are listed there. Things like the roast pastures and the stagnohumic or humic glaze with wet soils with humic accumulations on the top. And of course, there are effects on water quality. There's also the consideration of rooting patterns and the animal forms that occupy the soil, the invertebrates on the one hand, and the vertebrates, burrowing animals like badgers, and interesting things like the subsoil structures, like the one behind Yog, that on microscopic examination often appear to be made of little aggregates of fecal pellets from springtails. Next slide, just to show some examples. Freely draining soils in the top left picture, and in the foreground and in the distance, and wetter ground in the valley bottom with the roast pasture. It's gone again, Giles. Thank you. Badger set, where the badger has gone under the iron pan on the stagnant podsoils on the moor, using the iron pan as a sort of roof, and then the third slide on the right, showing quite dramatically a plume from clay soil catchment on the coal measures into the granite draining waters of the River Teign at a site which has always been a place to go and look for reds in the gravels. You can often see them from the bridge where the picture's taken from. Okay, next slide. Just a few thoughts on soil health. I would say that the soil survey accounts and maps could be regarded as anatomical text, as background text for the context of soil health, and that not all soils are the same. One's intrinsic properties are not necessarily there in other soils. They may be the symptoms of ill health. That the soil's morphological and seasonal contexts are key, that sustainable land use needs to be appropriate and timely. And just to add that the range of soils faced by a soil health consultant is nearer to that faced by a vet in a zoo than somebody working in Derriford or the RD&E. Next slide. The question really of what to measure and what to observe. I think an important measure from soil health, particularly the way agriculture has been in the last decades, Olsen P is important environmentally because it's shown that when the P index gets above ADAS index 3,
Are you muted, Tim? Oh, there you are. Lost the sound for a minute. Are you back? There you are.
Back now,
Yeah.
I hope.
Yeah.
You were just about to start explaining the Olsen's P indices above 3.
Yes. If you get above about 45 milligrams per litre concentrations, then the phosphorus tends to become mobile, and environmentally that is quite a serious issue, and particularly the way for all the time that maize has been grown, particularly by dairy farmers, the tendency to use the same field. It's not that true everywhere, but there is a lot of that goes on, and use it as a slurry spreading refuse. I worry about that aspect of it. But regarding observations, many soil properties need considering. Some are intrinsic and some are induced by land use. I can't see which slide we're on now. I think we need to go on to the next one.
We're currently on measure or observe.
Okay. Yeah.
Muted.
I think there are many properties that need observing. Some are intrinsic and some are induced by land use. Some need a pit and some can be seen from the surface. But there needs to be care with interpretations. I mean, worms are a useful indicator. They're not the only one, obviously, but I don't know whether people are aware of the formation of little worm castles, little clusters of stones around the burrows of the deeper burrowing anisic worms that you often get on tillage fields, and certainly we get it in our garden, which the worms organise at night. On to the next slide anyway. Has that arrived?
It's still on the same one, Giles.
Yeah.
That's it. Capping, runoff, and erosion. No?
Yeah.
Yeah.
Well, this is just a photographic demonstration of how capping happens in the top left photograph on a vulnerable soil with sand and silt particles detached by rain impact blocking the surface pores, which results in the sort of runoff that is illustrated by the two dye photographs at the bottom left. And that's taking place on a sandy soil in runoff not much more than 1 millimetre an hour. And then on the right, really is the upshot of this sort of runoff, where often the evidence of erosion is most obvious, particularly of sheet erosion, in the lower parts of the field where the sediment is redeposited. And of course, all of this has impacts on the land, on the environment, on the water. On to the next one.
This is compaction and poaching of grassland.
Yes. Well, the left-hand picture shows that the grass is growing in early spring, but these heavy soils are still very vulnerable to treading. And then the right-hand picture on the right, and it's well into May forage harvesting, but the ground on these surface wet soils, despite drainage, remain vulnerable. And on the same farm, on the same day, the freely draining soils half a mile away, not a mark on the ground. The next slide.
This is grazing late in the year.
Yes. This is just a piece of very top soil turned over, and if you look at it carefully, you will see that there are faint but very definite rusty mottles on the roots and in discrete places on the soil. And this is a common, not ubiquitous, but a common feature in grazed topsoils. And looking at 204 of the soil survey detailed descriptions of grassland profiles, this is recorded in 1 in 5 on well-drained profiles, and 3 out of 4 of the surface wet, poorly drained profiles. So that is an indication of a mismatch between soil health and grazing practices, something to look out for. And finally, I must finish. I could go on, but I ought to mention that there is a current Blackdown Hills AONB soil carbon project using the Honiton detailed soil map, but David Hogan would tell you more about that. But thank you for your attention and interest, and I'm sorry if there's been trouble for other people besides me with the slides, but thanks for your attention. Just to say that there's a lot of 40-plus-year-old soils information out there in danger of being overlooked or forgotten, and perhaps what I've said will help encourage some interest in that information. Over to you, Giles.
Yeah, thank you, Tim. That's great. I don't know if there's any questions in the chat. I think there's a couple there. I'll load up the next call in a minute, but let's have a look here. So, yeah, I mean, John Morgan's got a question around whether you could use, I suppose this is a bigger way of trying to take the sample, but they could use a modern tractor and post banger to take a soil bulk density sample. I don't know if that would be at all comparable or not. It's not,
I'm not sure about that. It would be interesting just to do some comparisons by a conventional method and his way.
Just to interject on that, sorry to interrupt, but there's some work that I'm looking to be doing this coming autumn on the pebblebed heaths in East Devon, and we're looking at sampling the soils down to a metre, and to actually dig through the soil profile is obviously quite a problematic on the pebblebed heaths. So we are looking at whether we can dig a couple of profiles to get manually to just try and get a feel for what's going on, and then go around with a pneumatic auger on the back of a ATV to take lots and lots of samples, and then find out if the lots and lots of samples average out to be what we sort of finding through the more manual, time-consuming soil profiles. And we'll see what happens from that. But that's a while off yet, and hopefully still subject to a bit of funding. But
yeah,
okay.
I don't know what your chances will be of getting down to a metre depth with a powered tool, because you know what the stones are like there. I mean, people always refer to them as ostrich eggs, and the soil survey used to have a drilling rig, and it would get stopped by those sort of things. But give it a go and see what happens.
Well, we've done it before when we were sampling for nitrogen up there, but so I know we can get down there. It's just the quality of the sample that comes out the other end is obviously really going to be a problematic. Yeah. But that's just something for maybe for another day. But yeah, hopefully it'll be interesting results from that and help answer John's question whether we can do this on a more mechanical way.
Okay, quick question from Tim Martin. I'm going to try and remember what the BD stands for, but if those bulk density, of course, yeah. If those bulk densities were pre-1990, do you think the heavy machinery used now, so up to sort of 25-ton tractors plus implement, will have upped the bulk densities? So I suppose that's a kind of a compaction question almost, isn't it? Impacting that.
It may well do. I mean, a point about density changes. It depends on timeliness of the traffic, whether it's by machinery or by cattle. If the soil is caught at the wrong time, then it gets compressed and the density goes up. But an interesting thing, this was never published, but two of the ADAS soil scientists at Starcross and along with myself and Steve Staines, who was based in St Austell with the soil survey for several years, we across a grazing season we repeatedly measured soil bulk density using a radioactive source, which I think is frowned on now because of its health and safety aspects. It wasn't published because there was a cock-up over moisture measurements, but it clearly showed on a range of sites in Cornwall and Devon, comparing freely draining soils against surface wet clayey soils. It clearly showed that over a winter, the freely draining grassland soils recovered their bulk density, or reduced their bulk density back to what it was the previous spring, whereas the heavy ones did not recover. And we always put that down more than anything to the higher biological activity in the freely draining soils compared with the heavy soils. So I think to answer Tim's point, it will depend on the soil.
Okay, that's good. What else have we got? I think that's a comment from Richard, and then yes, also a bit more about getting hold of some of the info and data that's available. Yeah, so Jörg or Tim, any thoughts on that?
Well, getting hold of the soil survey data, I mean,
yeah. Sorry,
you're frozen again, Tim, unfortunately.
What else have we got?
The handbook is available online, but it can be quite expensive. Sorry, you're back in the room now, Tim.
Yeah, the detailed soil survey publications have been digitized by Cranfield, but there's still paper copies in any libraries that exist. And I know the Northweek Library disappeared when Rotham took over, but I think if you know the right people at Northweek, you may be able to get a look at the publications. Also, the Devon Heritage Centre at Soughton, I think, have got copies of soil survey publications. And I mean, extracting data as was done in the tables that I showed was done by sitting down there and going through them page by page and writing down in the old-fashioned way, which is not particularly popular and well, it's not easy compared with proper computerized extraction of information, but it can be done that way. If there was a research project, a research student wanting that sort of information, they'd probably have time to do it.
Okay, thanks for those. One question here from James Burke, just interesting to talk about the phosphate within soils and whether there are any soil types you might look at more regarding sort of as sources of P, I suppose. So can we target certain soil types to manage P inputs? I suppose that's whether some soil types will either release more or hold more. I suppose they would hold more within a clay soil, but also in theory slower to release. Any thoughts on that?
Well, I think the problem comes when there is if there are high P levels in the soil. The problem comes when the water movement started, the thing that's going to vary as much as anything is the pathway of water movement, whether it's a very slow movement to ground if the groundwater is at great depth, as you might get, say, over the on the East Devon Plateaus, over the greensand, where it may be movement to the groundwater may be measured in terms of years, whereas on the clay soils, the runoff is complete within hours, if not a few days. So it's pathways more than anything. I think once you've got high P levels in the soil.
Okay, great. Well, I'm aware of the time, and we're just slightly behind time now. So I think perhaps if we jump into the presentation from myself and then Jörg on the SAT catchments, we'll do those. And if there's some other questions at the end or unanswered ones, perhaps repost them at the end. If we've got a bit of time, we'll try and catch up on some extra ones. So I'll try and bring up this presentation. Let's go and turn that on for that full screen. Whoops. Right. Have you got that one? Is that coming through?
Yeah, that's come up.
Great, thanks. So, yeah, so I'll try and get through this in reasonable time. There's a lot to talk about. So myself and then you're going to talk about the two kind of target or focus catchments we've been looking at in the Devon Cornwall Soils Alliance area, and so these are both special areas of conservation catchments, which is partly why they were particularly targeted. So I'll give you a bit of a background on a little bit about the catchment. Obviously, quite a lot of time has moved on since we first started doing this. I'll talk about kind of some of the investigations, walkovers, issues we found, and then we'll talk a bit about the soil types we were finding, sort of the soil assessments we've done, farm advice, and the various soil reports have been written for farmers, and then a little bit about some of the advice and remediation work we've done, some of the maize trials we've done with undersowing, and also try and pull out some of those kind of findings and conclusions. So the River Allen subcatchment, so it's a tributary of the Camel. It's about 5,500 hectares in area, and again picked out through its SAC designation, and it's designated for things like wet woodland areas in particular, and some interesting habitats, and also for 2 or 3 main species, so things like otters, salmon and bullhead. But it also has this WFD failure, water frame related failure for macrophytes and phytobenthos, and that's generally attributed to diffuse and point source pollution, and particularly things like sediment loss, things like that. So that's kind of the background and kind of why we looked at this catchment in particular. So you'll see, I'll talk about some of the soils now, and this is something that was produced before going out, which was really useful. You see it's predominantly kind of a medium loam soils and free draining. So it's about 80–85% sort of Denby 1 and 2. And then there's also just a few areas of slightly sort of heavier soils with a bit more silt, a bit more clay, and slightly heavier subsoil, so sort of Yodden Park, that sort of thing. That gives you a good idea, and really useful map to have before you go out. And you can kind of have it on you before you go out to those farms. So moving on. So catchment investigations, lots of the kind of usual things early on. Have a drive around, see what we can see. A bit here from kind of late season grazing. I think probably the cattle probably went in after by Christmas, but just kind of causing some issue there. And obviously that's coming because it's so near the road in the gate that's coming out onto there. Issues here with kind of maize near the watercourse and a bit of a slope, not much kind of overwinter management of those stubbles, which kind of a risk, especially after heavy rain, for example. And then here, similar sort of scene, kind of unmanaged stubbles after some heavy rain. And you can kind of see what's going on there. I think one of these will play a noise video. That gives you an idea. And then combined with that, trying to look at some of the sort of tributaries and subcatchments which had the most kind of mobilized sediment. So you can see this one here in particular, and that was this tributary on the left here. It doesn't come out that well here, but you'll see that kind of extra colour that's coming in from there. And this was done through one of the sort of heavy downpours in the winter. And so for some of those, it was important to try and get out in the catchment, after that heavy rainfall, just to give an idea of what was going on and some of the pinch points. I think the most recent one there, that was on a Saturday or a Sunday, but it was worth getting out there anyway, just to try and capture that and give me a good idea of what was going on. So kind of after that, give me a flavour of some of the things that were going on. The next part really was to look at a lot of the soils and do some assessments, talk to farmers, go and do surveys and provide feedback and see what we could see. So again, I'm picking out some of the not so good ones here, but we kind of had sort of again some unmanaged maize which was getting a bit capped at the surface and in patches had some compaction, particularly where foraging wagon and things have been harvesting, and again you've got a bit of a slope and a kind of a gateway at the bottom, so all kind of a potential risk. So then it was important to then have those conversations with the farmer here about what we think would be best to do. Getting things like the main thing, getting the crop harvested in time in good conditions, but then all the other factors as well. So perhaps rough cultivating afterwards, things like that, or getting in a follow crop if there's enough time. But again, a lot of that coming down to that kind of management advice. But good to go out and dig the holes with them and discuss that. Similar things here. This was a fodder beet, and again, this was lifted in not ideal conditions in January or December, and they tried to rough cultivate the top, but struggled because it was damp. And when I tried to dig through, I got down to about 4 or 5 inches, and then literally it was really quite a pan underneath. Luckily, the field wasn't too high risk area, but it's certainly one that could have generated a lot of runoff. And then so we had to have quite a few discussions about what could be done here and suitability of the field and this kind of harvest. Again, some kind of ones which are a bit more nuanced. So dug inspection here. This field, interestingly, was coming up a bit heavier, a bit more silty, a bit more clay, even though I'd just done some pits just down the road from it in kind of much lighter soils, kind of free draining stony soils. This just up the slope was a bit heavier and unusual, actually, on kind of a plateau at the top. And it was harvested in good conditions, had a good discussion, and it was drilled by the neighbour. But I think what we thought is that it was perhaps drilled, and when it was drilled in the spring, this field being a bit wetter than a lot of the neighbouring fields, probably drilled not quite in ideal conditions. And then that compaction's there been left during the crop's development and post harvest. So kind of interested in picking out the subtleties in the management there, and also that even if you get the drilling wrong, that can have like the sort of the carryover effect, if that makes sense. And again, I'm just interested here with the soil map being very useful, but kind of some of these fields here were heavier, and this is all Yellowland Park coming in here. And I suppose really what we were getting is, well, this was down as Denby, it was kind of the kind of transitioning, I suppose you would say, to see what people's thoughts on how quickly they change. But I think some of this heavier soil was kind of coming out here as well and towards these fields and overlapping. But that's what we were seeing there. And then a lot of the quite a lot of the catchment is down to grassland still. And so there's a lot of digging holes in the grassland, discussing that. Most of the grassland had kind of sort of moderate to light compaction, as you might expect, more around the kind of yard areas. But in this example, this actually had a bit of a combination of outwintered cattle and a few ponies, which can often lead to a bit of compaction over winter. You will see that mottling quite clearly here. So there's some slightly more obvious examples of compaction we were seeing. So what were some of the themes? Well, early on, I noticed to say there was quite a lot of sort of unmanaged maize stubbles over winter, with the risk kind of being either no kind of rough cultivation, or perhaps trying to put in a winter cereal and not necessarily getting enough establishment before winter. Again, some of the kind of the big ticket things were soil structure after kind of late season harvests, so things like also fodder beets and potatoes, which were present in the catchment. There's also a few things like daffodils as well. Quite extensive sort of pitch of shallow compaction, but generally kind of only to a moderate level, so it kind of could be improved, but not severe, but on a kind of a wider scale. And then so there was a few kind of incidents where perhaps some of the slightly heavier soils there were being managed in a similar way to the very free draining Denbys, which is then kind of causing a bit of an issue. And actually this photo here is just that interesting bit of heavier soil, actually on the plateau at the top where the water was standing. Lower down, you wouldn't get this at all. It would just, drain very quickly generally. So a couple of things that were done. We did make available some partial slitting, and we had a glass and grass and aerator. Just see that on there. So this is where we'd sort of identified some shallow compaction. Had some reasonable feedback with this. I think it's quite difficult to try and pick out the kind of before and after impact. I think it's kind of more of a little and often type approach. And it's something we did find a bit difficult was, for example, this autumn, you kind of need the grass to be grazed tight enough to be able to use this easily without pulling up bits of grass and root. But because we had a very mild autumn, there's a lot of grass around still. So there's too much grass, and then by the time the grass is grazed off enough, it became too wet. We were too late into October. So that was a particular problem we had this autumn, and can be an issue using this implement, because you've got quite small windows really, either in the late summer, early autumn, which we've tended to use it, or in early spring when the ground is drying up. So we're kind of getting towards that period now, hopefully, if it keeps dry for a few more days. So some of the other kind of demos we did, there's a couple of farms in the catchment which we did some undersowing experiments, and there's also a few we did on the Foy catchment as well, which kind of helped give us a bigger group to discuss things with and demo. Again, one of the difficulties here bringing a specialist machine down from East Devon was getting the timing right. So people's maize were at different stages between farms, and even people with the same farms, some were slightly ahead of others and not. So this machine tends to go through when the maize is kind of ankle height or just above, and it goes through that. But it did generate a discussion, a lot of interest. I have done a little blog and vlog on this if you want a bit more detail, but as you know, a key point of that you'll see is it's just an extra tool that can be used. It doesn't mitigate all the issues of your correct management. So your sowing dates, variety, sort of field topographies, slope, warmth, sunlight, when it's being harvested. So those are all the key things. This is just something extra that can be used to assist with harvesting. So there's a particularly good tractor driver we had for this, and there were a lot of positive comments on that, because that could go wrong quickly if you weren't concentrating. So generally the ryegrass established well between the rows. A couple of demos with paddock mixture didn't really work so well. It's just too slow. In some ways, it'd be nice to get something with a bit more mixed in there, but I think it just doesn't grow quick enough. That's one of the issues. Some of the feedback initially was kind of positive feedback, but it's can be quite costly, and so those costs need to be kind of gained back by the farmer, perhaps by having more forage next spring, something that can be grazed or cut, and retaining nutrients over the winter. So that just gives you an example on a larger field, and this is just a picture here where one side's been done, one's not. And so mentioned most of that there. So one of the farms has bought are into row drill more likely. So we'll have to have a discussion and see if they're up for sort of sharing that as well. And then also we did get some extra advice in the catchment. So I had John Morgan come down from Quid Associates to give some advice to some of the bigger maize growers within the catchment. I think it was 3 of the main growers in the end. And there were some interesting things that came out there. It was useful to kind of get that extra independent advice. And quite a few of the fields were being picked out as being quite high risk. So there were a lot of fields there are quite sloping. There's a lot of watercourses. So then, again, coming back to this thing about variety, choice, sowing date, alternative forage options really being important. So to try and conclude a bit and moving on for the catchment, and so we've got that real high demand for land availability. There's some bigger farms there and some bigger arable farms, and they're really trying to kind of get a lot of the land that's available. there's probably kind of a few larger enterprises managing most of the catchment, but there's also some kind of more conventional smaller mixed farms alongside. Tend to find there was kind of scattered regulatory breaches, particularly on these kind of bits of land that were kind of short-term rented on off-ground, for a particular crop. So, potatoes put in for a bit, or daffodils, something like that. To give you an idea, so quite difficult to quite complex understanding some of this. But there are over 20 farms when visited, probably near 25, covering nearly 2,000 hectares. It's just under sort of 40% of the farmed land, so a kind of a good area covered. Like I say, that mapping probably doesn't cover all of it, because a lot of those bigger farms were sort of short-term renting a lot of the other land as well, you see in the catchment. And also, in particular, working with some of the environment officers in the Camel, as it's going to be an area of increased kind of enforcement, making sure and stuff on the same hymn sheet. So when we talked earlier about the catchment and what we thought, well, what's happening here? Why is it failing WFD? How much of it is advice, grant, regulation, land use? Again, my comments are sort of similar here. There certainly are some of the issues picked out are kind of probably regulatory breaches of some kind. So perhaps farming rules to water, where there's soil loss coming out of fields and gateways, things like that. So would better enforcement help? It certainly would. Not in all cases, but it would. So I've commented there that perhaps it would have the biggest impact, and perhaps around kind of 70%. But there are also other areas where we either need advice, in particular, grant assistance, but also there will be instances where I think the land use choice may need to change. So perhaps you've got a higher risk crop, perhaps in a higher risk place. So further up the catchment, it gets quite steep. It's not so warm. It's quite wet. Need to make sure that the land use there is appropriate. And maybe without some of those changes, the catchment won't be compliant. So again, I've just tried to capture some of that here, where there's this big demand for growing quite a lot of these high risk crops, and when you consider that and the amount and the need for rotation, there's not always that much kind of sort of good quality land, I suppose, that's suitable to grow. So that's where we kind of have these issues, and there are, say, these gaps in mitigation that's required to grow these crops sustainably. So conclusions. So there is evidence in places where the farming practices aren't matched to the capability of the land, where it's something too high risk for the area. The livestock density is quite high there, and often can generate high phosphate indices just because there's a lot of big enterprises there. And again, as I've mentioned here, trying to get suitable fields to allow for those rotations is an issue. And so as we move up the catchment, it is kind of cooler, wetter, start to get quite elevated, and so that can limit the suitability to some of those other crops. So that's that for that. Probably if I close that one and get Jog to set his up, if you're right, Jog, and then perhaps we'll do the questions at the end if that's easier. Oh, you have to unmute yourself, Jog.
Oh, yeah. I was just wondering if we want to have 5 minutes for people to have a quick comfort break, or
yeah, I did think that as well. It's long, isn't it?
I'm of an age, I'm of an age.
That's fine.
Yeah. So if anybody wants to really, we'll start back at say 12:05, and then
yeah,
I'll set my slides up.
That's great.
Okay, hopefully most people will have made it back by now, and I'm conscious of the time myself. Good afternoon, everyone. My name is Yog, or Yorowith. I work for the West Country Rivers Trust. Some of you may know me, but what I'll do is, because there's obviously the work that Giles and others have been doing on the Allen is very similar to the work I've been doing on the Axe. I'll skip through several sections of mine just to create a little bit more time for Jack following this. But also, I'm going to just talk a little bit more about the some of the issues that have come up that have been relatively unique to this being a purely soil focused project, really. So I don't know whether you can see my screens moving. Is it moving, I hope?
Yeah, I think so.
Excellent. All right. Well, here's a brief précis of what's been going on. On the right-hand side, you can see the catchment documents which were created to give you the sort of the desktop understanding of what the catchment's up to and what's going on and all of the things that we've previously mentioned. But and I brought this up first because this was the interesting concept for me, because this is an EA funded project through WEG, Water Environment Grant. The involvement of the EA puts us as advisors into a relatively unique, well, not unique, but awkward situation sometimes, but sometimes a really powerful situation. And I found the dynamic of working with the farmers in the Corrie Brook, and I've worked with several of them on other projects previously, but the EA letter that was sent out at the beginning of the project, it basically just said the way the money was coming from for the project, what the aim of the project was, and this has all been covered by Giles with regard to WFD failure for sediments and stuff like that. That set a precedent in the minds of the farmers before I even then rang them to ask them if they wanted to have a visit from me to come out and we'll talk soils and go out and dig some holes. But you've got to remember that the Axe catchment as well, several of you will have seen the report that was done by John Cousins from the Environment Agency on the state of the Axe from an infrastructure point of view after his numerous visits to some of the larger farms in the catchment, and many of which were also included in the Corrie Brook, meant that the conversations with the farmers could be, even from an outset of when you haven't had a huge amount of background knowledge of that farm previously, can be a lot more frank quite quickly because of the fact that they were fully aware of the situation. They were fully aware that things were changing, and they were also fully aware that their place in the catchment and within both the Corrie Brook and the wider Axe catchment was being watched, inverted commas watched, but also the fact that they knew that things couldn't carry on as they were. So the EA letter set a really good baseline for us to go, not baseline, a foundation for us to be going out on, in the respect that I have yet to have anybody tell me they don't want me to come out and visit. So there's basically that EA letter has sort of given me greater access, I think, than you necessarily, or maybe swifter access anyway, to a lot of the farms. But you're also then in the situation where you're going to be out and doing the wet weather surveys. So once they know the colour of your car and they see your car going around in the wet weather, that obviously changes the dynamic a little bit as well. I obviously carried out the soil assessment visits that, like Giles had just been discussing. I'll cover a little bit of that later. We then offered the mitigation options. Again, Giles has covered much of this, but the problem is with the mitigation options is the fact that we were hit a little bit by COVID because of the fact of trying to organise times of operations in fields and everything else when you're trying to do it remotely via a mixture of contractor and farmer and others. It's much easier when you're going out and digging the holes, going, right, it's ready now, you can bring the kit in. But when you can actually go out, it gets a little bit awkward. What this did lead to, in some respects, was several of the farmers were doing their own work off their own bat. If I, for example, as one of the farms has got quite a lot of sheep up on the plateau, it had caused quite a lot of surface compaction there, and I was recommending, we were going through what was obvious and what was being shown up, and we talked about the use of an aerator. But because of the problems with COVID and everything else, he ended up saying, "Oh, it's fine," and he went and borrowed one off a neighbour and started using that. And he was very positive about the impact of it, and he could completely see the impact of what was happening. But the thing with aerators and other bits of kit, it's not necessarily with what they do immediately. The aerator is obviously less impactful and doesn't cause as big a change as a subsoiler. It's much more about what you do post that, so that you don't solve the problem and then just go back to what you're doing before, thinking there's nothing else to be done. I'm covered. So it's all about the long-term impact of that, which again we'll sort of have a bit of coverage in a minute. And then, as we've talked about with Becky and others earlier, the soil organic carbon sampling was also carried out on 5 of the farms in the catchment, as they were trying to take their soil knowledge onto the next level as well, but also just wanted to have that as a baseline, so that when it comes to any future works that they're doing, they'll have this as a reference point to go back to. And we've had some questions on this in the chat already. It's a lot to do with obviously understanding that whatever protocol you choose, you need to make sure that the same protocol is followed out for the next one. If you want to try and assess these and have equal comparison, you can't have one method now and then introduce a different method halfway down the thing and then try and compare and contrast, because it's really important that we have some stability in that. Just as an aside as well, I also had quite a lot of time to put towards the FIPL project, the Farming in Protected Landscapes, through the AOMBs. So I was allocated some time to actually spend with the farmers on the Corrie Brook, which I was already doing through this. So that was a bit of an awkward one in trying to keep taking my hats off for different projects and stuff like that. But where there were opportunities that I could see them for FIPL, then I was carrying that out, and that will continue into next year as well. But on when you're out sampling and it's raining and you're wet, and then you see that going on just across the valley from you, you're thinking, right, and that's the farmer I need to go and visit. And to be fair, I went to see that farmer, and he was very accommodating, and he appreciated what was going on there, and then did point out the fact that because I took this and took me a while to actually get onto his farm, not because he was being awkward, he was just trying to find out who exactly was running those fields, because as Giles was saying, it doesn't always work out that the nearest farmer is the one who's running the fields and stuff like that. But in this case, it was the guy. I'd had an interesting visit from John Cousins, and in the time it took me to take this photo and then go out and see him, he built a massive slurry store. So in his eyes, he won't be doing this anymore, but he could fully understand why it was a problem at the time. That, to me, though, is brilliant, but to have the regulation in place. It doesn't necessarily then solve the problem of phosphates or anything else, though, just because of the fact that he can now have the freedom to be spreading at much more opportune times for both the crop and for the soil's ability to take the machinery and want to have that phosphate. It's just whether there's already too much phosphate in that part of the world anyway, and he's just got a big store of phosphate at the top that he wants to spread, but that phosphate needs to go somewhere, and he might not have the access to enough ground to equally serve the requirements. You also come across things like this, early doors of that. Again, this farmer is on my list and has been spoken to. This shouldn't be happening again, but you can never guarantee that. But this is the main Corrie Brook here, so I think that's a pretty blatant look at farming rules for water and what you need to be talking about when you're going to visit these farms. But the one thing that a lot of people that I like about doing these sort of projects, where they are quite focused and you're in an area for a little bit of time, is you see the change in dynamic of the landscape across a couple of seasons. Most of the work was carried out in the autumn and the winter, but just having the chance to go out in heavy rainstorms in the summer and stuff like that helps you see things. But also the fact that when you're out digging holes in one person's farm, you're seeing lots of other people's farms and their actions in the distance as well. So that sort of thing then can lead you to follow up more stuff as well. So I think it's just it's a really interesting thing to be doing when you're focused that much. These are the soils. Basically, you've got mostly Wimple, which is this section all the way down through here, Wimple 3. And then you've got your Batcombe, so you've got Dunkeswell here and then Batcombe. This is the Devon Plateau, which Tim has mentioned previously, and this really is quite flat ground. So this is obviously where you'd be logically thinking to do your work, but not necessarily that the soils there are the ones that you want to be working with. But the farmers do. And the thing is, there's also a perception within the farming community that this flat ground here has absolutely no connectivity to the river, which runs quite closely on the edge of the catchment on this side. And you'll see that in a second with the slopes. But then you've got the Hence and the Bearstead series soils. So this is mostly Hence up here, and then you've got Bearstead above it, which is classic, where you get the clay flints on the top going into really free draining Bearstead soils into the green sand, and then where the green sand starts to empty out, you get into your Hence series soils on the sides there. But the topography of this landscape, which you'll see in a minute, is actually really quite different. And basically these are the very flat fields, so you can see that if it wants to run, it will run, and it will make it to the river. It's just how quickly it gets there. They weren't quite seeing that connection, that's for sure. But I took a group of advisors and staff from the Environment Agency and others up into this area a couple of weeks back, and we were probably around there. And when I was showing them where the flood impacts were from when the river had come out of its channel, it was amazing that in such a small part of the catchment, you were still getting really sizable, flashy nature of what's going on. And that was an interesting thing to show them, that you don't have to be a long way down to suddenly get really quite impactful volumes of water being generated. So this is going back to what I was saying, this is where you've got these really quite steep sides here, which is your plateau on the top, which is all nice and everybody thinks they can work it, but the soil type isn't as forgiving, and it's reasonably high up as well. And then you've got these really quite steep sided slopes, and this side of the valley is pretty much all grass, with some with that not all being permanent. And then the rest of the valley, apart from obviously the steep sides up here, is either woodland then, or it's mostly well, there's bits and bobs of arable, but it's mostly new lays and stuff like that, which is basically set for dairying, and it's set for having quite high turnover on their silage lays. The land ownership, it looks quite complex there in the respect that there seems to be a hell of a lot of people, but as Charles was saying, and you'll see in a later slide, I worked with a hell of a lot of the farmers, but there aren't as many as that gives the impression. It's more the fact that there's a lot of farmers have either given up and basically they still own the ground, but they're renting it out to their neighbours, or there's a lot of people that have bought more ground than they necessarily is somewhere within the family. It'll be their dad's got it or something like that. Basically, this is a map of the 20-odd farms that have had a report so far. This doesn't include, it's like this bit of ground here, all of this up here, there's gaps in there as well, and there's more ground up here that I've actually dug holes in. It just hasn't filtered through yet to this map, which is a bit frustrating. That's my fault, and I need to apologise to Frank for not getting him all the information in time. It isn't finished yet, and if we do manage to get the definite sign-off for the extension to this, then I'd like to go out and visit a few more of the farms. I've done all of the major farms. I'm comfortable that the people I've covered are the ones that I think really needed to be covered. But another element of this, which I think is really important as well, is, as you can see, when you've cut out the rest of the catchment and you've just, this is the Axe catchment, and obviously this is the Corrie Brook. When you're talking to the farmers, their land, they don't just only buy land within a catchment. They buy land and it goes across watersheds and into the wider catchment. So one of the guys up here, I gave him a load of advice about his ground, but he owned 2 farms, one of which was reasonably close, but in the Yardie. So it's the knock-on impact of the information you're given doesn't just stay within the boundaries of a watershed. It can actually trickle out into other ground, as long as the people that you're giving the information to understand the dynamics of, is it exactly the same soil type, or is it actually similar practices going ahead, and not try and be a catch-all and just solve all of their problems in one fell swoop. Just a couple of typical things that you just come up against, but And this is a couple of pictures here just to give one thing that really frustrated me at the same time as I'm loving having the interaction with the farmers and them coming out and digging holes with me and stuff like that, which you don't get to do very often. It's much more about you'll have the conversations in the yard, you'll go out, dig the holes and then come back and report what you found. This was good having the farmers actually physically out with you in the field and going through a lot of this. But this one is a good example. You can see the wetness in this top section here. And when the farmer was like, I want to go and have a look at that part of the field because the rest of this field is great, he said, but I never get what I want out of this bit. And if I can just quickly, hold on. I mean, you can see there, I mean, that's 30 centimeters down. It's just pure clay. You went, bloody hell, that's close. I didn't think the clay would be there. And it was just quite a simple thing. And the fact is, it always holds water there. I said, well, if you dig down, you'll find out the rest of it was really quite free draining, even though it basically went from a clay loam down to a clay loam with a higher clay content, whereas this was sort of a clay loam directly over clay. So there was the free draining of that. And it was, as you can show here, sort of 25 to 30 centimeters deep. He was there going, oh, right, well, that answers that question. So then he was there going, well, we won't be using that part of the field quite as much then. So it just changed the dynamic of the field, the way he was looking at it. But the other thing that, and that's the impact of how far what that clay was looking like. But this field is the same thing, but it's slightly different in the fact that the rest of this field was actually quite good, but this is the headland and the Corrie Brook runs down the bottom of this field here. But the guy who was running this bit of ground had rented it out to, sublet it out to a younger guy who was farming this. And he said, yeah, he's doing a really good job. And I said, well, that's compacted. He went, well, that's just the way soils work, isn't it? That's what they do. And I was amazed because he was quite an old guy. And I was there thinking, well, he wouldn't have worked that soil at the time. He went, no, you can do that. And I dug a hole there with him and it absolutely stank. And the rest of the day that I was with him, he just kept referring back to it. I couldn't believe that. I couldn't believe you could do that. I thought it was just that it was lying a bit wet naturally, but underneath that it was dry as a bone. And that's the thing that really I thought was brilliant in the fact that obviously he's had this slight moment of realization, but at the same time it was worrying the fact that he thought, oh, it's just lying a bit wet and therefore I'm going to worry about it too much. It'll solve itself over the course of the crop growing. But it was incredible that he was so sort of detached from it that he didn't think there was much of a problem. As soon as you showed him the problem, and to be fair, he wasn't the only one that this was the case on, I think his thought process was immediately, right, well, we can't keep doing that then. But whether that actually manifests itself in the fact that he won't do it, that'll be another thing. Just quickly then, one thing, this is another classic where obviously there's people working their ground a little bit too close to the river, and you can see it's a really nice slope coming down to the river as well. Everything was against that in the respect. So that guy has told me he's not going to be doing that again, but we'll wait and see. But going back to what I was talking about, the flashy nature of this soil, this catchment, sorry, is where you get the roads doing what they do on these quite small catchments where they run perpendicular to the river, especially with Devon banks and everything else. You get quite a lot of pooling up of the floodwaters as it sort of expands out into the ground either side of the river when it's over top in its bank. And you can see by the amount of sediment that's dropped out in these sort of stagnant-y areas of the flood, just how much is being carried in these storm events. And there's obviously evidence there of like really quite significant levels of water. And the thing that also I think needs to be factored into this is not just necessarily the case where you've got compaction causing the excess runoff. And even though you might be getting excess runoff of sort of grassland fields, it's the volume of water and its interaction then with its banks is obviously really important in understanding the levels of sedimentation in the streams downstream of these points as well. So where you get excessive bankside erosion, this is close to a bridge, where basically the bridge had caused a backing up and the river to start trying to interact with its floodplain, but ended up causing a big eddy sort of style bit of erosion. It had taken out most of a gateway of a farm with its access track into here. But I think there's an awful lot of sediment in the system now that wouldn't necessarily be there just because of the excess water in these flash floods not necessarily taking it direct from the fields, but entering the watercourse that much quicker, and then causing excess erosion of the banks of those streams, but also of the bed of those streams. So the beds are going down, which means they're not interacting with the floodplain as easily, and therefore they're getting deeper and deeper erosion, sort of a catch-22 style situation. So very briefly, similar to what Giles was saying here, I mean, the one thing that does get me is farmers that tend to farm the geography they wish they had, as opposed to the geography they've actually got, and being led to sort of farm in a way that they think they have to do to make money, and they are being pressurized from all sides, and I completely understand that, and it's no way is it simple, and I think we need to make sure that we understand the fact that it's not simple, and we don't just come in and go, well, you just do this and then just walk away thinking that'll solve it all. You can't. It's much more complex, and it manifests itself in so many different ways, and with the pressure as well from the government for changing through ELMs and stuff like that to sustainable farming incentive, there will be parts of this catchment it will work perfectly, and other parts of the catchment, those farmers, I cannot see them ever wanting to be a part of this. But maybe the good that you're going to get at the top of the catchment against the bad that you're going to get at the bottom, the output at the confluence will probably remain exactly the same. So, or probably worse, depending on the level of take-up. So we need to be wary of that, and we need to be aware of it. But basically, I've just got the things here. There's obviously a work in progress. The mix of regulation and incentivization is massively important, and the fact that you've got even though they're not physically there, the thought of the Environment Agency behind you when you're talking to the farmers, I am convinced that changed a lot of the conversations I was having, and the want to do things, and getting things like farmers inviting me back out to look at them doing some subsoiling, to ask if they were doing it at the right depth and stuff like that. And I was thinking, well, did you dig a hole into it? Well, can you come and dig the hole with me? So you go out and you dig the hole, and they making sure they were doing it at the right depth. So all of that sort of stuff, I don't think would have happened so much or as readily if the Environment Agency hadn't been in the background. I still believe we need a wholesale change in attitude, but that's obviously going to be driven by many factors, as I've just said, and follow-up visits are always going to be the way forward. But fundamentally, we need to remove this fundamental removal of the shift in baseline syndrome. We can't have farmers thinking, well, it's always been like this based on the knowledge of the last 20 years. Or based on the last 30 years. We need them to understand how can the catchment be, and look at when it was in various timeframes, and see whether they can fit their current farming practice to get things back to where we're going to be in a situation where the river is behaving as a complete unit, and all of the contributions are being factored in, and we're ending up with a much better, more sustainable catchment instead of being pushed to the hell in parts. And that's a whistle-stop tour of the Corrie Brook.
Great, thanks, Jörg. That was really good, and I like the way you got some of those points across, because it is complicated, isn't it? And trying to explain it and those thoughts and feelings. So that's good. Perhaps if there are any questions, if we get a chance at the end, we'll address those. Otherwise, perhaps if Jacqueline wants to share her presentation, let's give you a quick sort of biography on Jacqueline. So. Jacqueline's a senior research fellow in pedology at Cranfield University, and leads on the soil informatics group. And she's also currently part-time on secondment with the Welsh Government soil policy team. And a lot of her research centres around kind of soil data, digital mapping, and soil health. And also worth noting that she's the president-elect of the British Soil Society of Soil Sciences, and vice chair of the International Union of Soil Science, and also associate editor of the Journal of Soil Use and Management and Soil. But as we're a bit late on time, I'll hand over and let you make a start.
That's fine. No, thanks for the introduction. I'm kind of presenting under my Cranfield hat today. Probably see I've got a few. Thanks very much though for the invitation. I'd just like to thank the other speakers actually for really interesting talks that we've had so far, especially working with farmers with catchment management. So Giles and Jörg asked me to give a a kind of talk looking more sort of broadly, I guess, at soil carbon, you know, what the trends are, what the mapping is, what we can do. So some of these things have been touched upon already. But just to kind of go back to something that Becky touched upon earlier in her slide. So, you know, there's a lot in the media at the moment about, you know, the soil saviour in terms of climate change, mitigation, storing more carbon in soils. But there are also, you know, lots of other co-benefits to increasing or maintaining soil carbon in soils as well. So we kind of think about that in terms of the soil carbon store, providing the food source for, you know, all of the soil biology. So not just earthworms like in the infographic, but all the microorganisms, and those are really key to providing nutrients for plants. So making that nitrogen, phosphorus and potassium in a form that's available for plant uptake. So, you know, a key part of that cycle is then the provision of food for soil biology, for growth and respiration, but, you know, as a co-benefit for that, they're also then breaking down those nutrients in the soil organic matter for them to become available to plants. Increased carbon in soils as well. You've probably seen, if you've dug lots of pits, you know, differences in just the structure of the soil as well, where there are different organic matter contents. You start to increase the porosity in those soils, which in turn means that, you know, they're able to accept more sort of excess winter rainfall. They can drain much quicker. And also the carbon itself can absorb lots of things like excess nutrients and also, you know, pest control products as well. They help in the degradation of these sorts of things. So it really is a kind of, you know, that's why people bang on about it all the time, a kind of keystone property really in soils, because it has all these other co-benefits. So not just maybe the one that's in the media at the moment about climate change. So it's really key to maintaining, if you like, I don't want to use the term, but soil health, if you like. And I wanted to kind of touch upon, because a lot of people talking about stocks, and I'll talk about that in a bit more detail in a minute, and the concentration of carbon in soils. But it is a dynamic system. That this is a natural system where the carbon, through inputs from plant material, through the roots, through the biology in the soils themselves, they are a source of carbon in the soils. So there's this cycle of all of those inputs, but that carbon is cycled, it's broken down within the soil profile, and again, you know, released again as carbon dioxide from the respiration of those organisms. Because CO2 is needed by the plants, so we need to have this cycle happening all the time in order for plants to be sustained. So, you know, just kind of like to reiterate that, you know, that is a natural part of the system. We've obviously put more CO2 into the atmosphere through burning fossil fuels, but naturally that system works as a cycle. So it's operating both as a sink, so storing carbon, but it's also a source of carbon as well. So that's something to bear in mind too. And what we're trying to do is then make sure that we've got this kind of balance, that we're not then taking too much of that carbon from that sink, from that store. And I'll give some illustration a little bit about what's been happening in terms of the concentration of carbon in soils over sort of longer timescales through monitoring. So this cycle is, you know, really important for those sort of delivery of those sort of ecosystem services that I talked about in the slide before. So the provision of the nutrients, so that carbon is being broken down. So those nutrients are being then released into the soil that can then be converted by the microorganisms and taken up by the plants. And so we talk a little bit about carbon or organic matter in soils more generally. And there are lots of different sort of types of organic matter, if you like, and they have different lifespans in the soil. So some of them hang around for a bit longer than others. You've probably looked at some, maybe digging up sometimes, particularly looking at those sort of maize fields, the stovers and things that take quite a long time to degrade. They sit on the surface, especially if the soils are quite wet. So we've got this kind of these pieces of decaying plants and sort of animals and things of what we kind of call particulate organic matter, those sort of things you can see on the left-hand side of that figure there. And these are a bit like things what I'd call like your current account of your bank account. So I don't really want to reveal necessarily too much about my spending habits, but you think about the organic matter here. This is readily available. You've got regular inputs from plant material or roots or from the microorganisms themselves, but that is being used. So I'm spending, you know, I need to pay my mortgage, I need to buy the kids new clothes. So there is that carbon being cycled and released again as carbon dioxide. This is fine, that creates that cycle. And then we've got other types of kind of organic matter. It's a little bit more, it's a bit harder to get hold of. So this is a bit like your savings account. So that's where you start to accumulate then your carbon store, and that's what we're looking at, trying to put some of that carbon into this sort of long-term storage. And these are organic molecules. So they've probably gone through these various cycles of this particular organic matter that's been degraded by microbes. The microbes themselves get degraded by other microbes, and you start to get this very diffuse form of carbon. And eventually that can stick itself to minerals in the soils, and it's very difficult then for those microorganisms, for the bugs, to get hold of that and to start to degrade it. But in systems where you're not putting a lot of that sort of current account carbon in the soil, the microorganisms will look for some of that carbon that's locked up in the savings account, and they'll start to degrade it. So if you think about changing that system, or you're exposing those aggregates, so the carbon that's within those aggregates through things like tillage, you expose that carbon then to microorganisms so they can start to cycle it a bit. So it's, you know, it's quite a complex process of sort of, you know, inputs and outputs and the cycle of carbon and organic matter in soils. So it's sort of seen as, you know, quite a dynamic process that's happening. And there are various things that are happening at very short time scales. So the turnover from microorganisms to longer time scales, which is like this build up of your savings account, which is your carbon stock then. So yeah, we talked a bit about, you know, looking at baselines and measuring. So we want to find out, this is a sort of snapshot, if you like, about, you know, how much carbon actually is stored in the soils. And Tim gave us a really nice explanation, taking us through how we calculate that, you know, for a particular soil in Devon. So we need, you know, information on the carbon concentration, but we also need the bulk density as well. So the unit volume and mass of which that carbon is stored. And then we need to take into account, you know, how many stones are in that, so that in that calculation as well, to adjust for that. And this map is, you're probably all squinting down at the southwest there. So the darker colours are where we've got higher carbon stock. So those are in those sort of upland areas where we've got peaty soils. And this data comes from the data that Tim talked about earlier from the Soil Survey of England and Wales. So we've got samples of soil to depth for particular soil series, and then this is then associated with the map. And I remember presenting some of this slides before, actually in a workshop with Tim, and he corrected me on the number of person years actually that this data set took to sample and interpret and to map. So I originally had up an estimate of about 400 person years through all the activities of the Soil Survey of England and Wales, but Tim then recalculated it and said it was probably nearer 2,000 person years of all of this data collection that we have. So this is quite a significant resource. So this is based on sort of physical samples, but we're kind of constrained a bit by the level of detail of the mapping. So I think Jorg showed some maps earlier where, you know, there was uncertainty in that mapping because of the scale of the mapping of the national map. So there are different ways where we could increase the scale of the map using different types of approaches now. So we're using all sorts of things like machine learning. So very similar kind of algorithms that are used when you're on Google, or you're on some other things I won't then advertise, but you know, they're learning from your behaviour. So basically they're looking for patterns in data, and that's exactly, we're applying those same sorts of algorithms to look for patterns in data. So we can take all of this data from the soil survey and put it with other types of data sets that we now have at much higher resolution. if you think about the hydrological pathways that Job showed in the last slide, we've got, you know, very detailed data of the terrain, and we can start to associate perhaps where the soils are changing in those different terrain positions. We can start to overlay things like land use. So this is a modelling exercise where we actually then could predict those properties based on these sort of pattern matching, if you like, or association of the data. So we can start to increase, if you like, the resolution of the data sets that we have. This one was produced by a student that I was working with. So we've, you know, predicted on 100 by 100 metre grid square, for example. The good thing about this, you can sort of quantify the uncertainty, so you can give an estimate of how well that model has predicted the carbon. But, you know, just to remind you that it is only a prediction. So, you know, it's not necessarily reflecting reality. It's based on what the model thinks is happening. So what is then happening? So we've got a kind of snapshot there. We can sort of say, OK, this is where we think, you know, what the carbon stock is. But what about how it's changing? So again, this is from data on the left-hand side is another survey that was done through the National Mapping Programme for the Soil Survey of England and Wales. And each one of those points is a 5 kilometre grid square on an OS map. And a sample of topsoil from 0 to 15 centimetres was taken at each intersect of that map. This was repeated, so that was a programme that started in the 1970s, and there was a sort of rolling programme over 4 or 5 years to sample all of those sites, and then it was repeated around about 25 to 30 years later. So there's another set of samples in the early 2000s. So we've got 2 points on a graph. There's also another national data set, so this is held at CEH. And this is the countryside survey, slightly different way of sampling the soils, where they stratified the landscape by habitat and then chose random sites within that to sample. And they sampled soils as well as habitat indicators as well. And this was resampled about 3 times over that same time period. So what's happening to the carbon then over these sort of longer timescales? So this is a collation, a very brief summary of what's happened to some of those soil properties over that time for both of those surveys. So both of them agreed that carbon content had decreased in arable sites over that time period. In other habitats, there was some disagreement between the different surveys, probably due to the way that they were surveyed. So you can see in that former slide, they were quite different in the way they were structured. And there's just some other data there also that was sampled. Other properties of the soils were also sampled as well, so pH and available phosphorus. And that increase in pH is mainly due to the decrease in acidification from acid rain over that period of time. So we've, you know, it's been highlighted from sort of national monitoring, and you might notice the date on that. Nearly 20 years ago was the last systematic kind of sampling that was done in England. In Wales, there have been some continuation of the countryside survey through the Glassdeer programme, so there is a bit more data for Wales. So we talk about, you know, these sort of national programmes have given a snapshot of, we're seeing a decline in certain land uses, but, you know, there's now opportunity for sampling and monitoring soil organic matter, and also at a much finer scale than those national mapping programmes can sample at. So various incentives. Becky's, you know, doing great work. So trying to think back to her talk at the beginning of the morning, where, you know, they are systematically collecting samples for soil organic matter and soil carbon on farms as well. So these are linked to, you know, these toolkits and carbon accounting. There's also policy drivers. So someone mentioned this in the last talk, you know, through ELMS and the sustainable farming incentives. So those initial soil standards that have been released already by DEFRA indicate then soil assessment and sampling for soil organic matter will also be required on a proportion of land. So there's opportunity now for, you know, increasing our knowledge about that baseline, and, you know, taking into account that some of those observations were made 20 years ago. You know, we don't have an idea of the current state or the stock of soil carbon in soils at the moment. So I don't want to finish too much on like doom and gloom. So, but you know, there are opportunities obviously to sort of increase or sort of maintain then organic carbon where we've seen a kind of depletion. Becky did talk about this in her talk a bit earlier, you know, about some of those opportunities that we have. One key thing though, you know, to point out, and there's some great data that Tim showed us in his talk, looking at the carbon stock in those upland soils and those upland fringe soils. So looking at peats and these sort of organomineral soils, so these topsoils, and also their subsoils. So that was great. I had this in my talk already. So, but Tim mentioned it earlier that actually, you know, in the subsoil, there's also quite a high, in some soils, there's a, you know, high concentration of carbon as well at depth. So a key thing is then, you know, for these soils where there's already a large carbon stock is actually to try to maintain that stock. And then where we've, you know, we start to see that depletion, you know, obviously the opportunities in arable sites, then potentially to change land use, change land and soil management. And, you know, you obviously will see the greatest gains in those soils like the one on the right hand side that have shown historical kind of depletion in carbon. So I'm going to go through in a minute just a couple of those with some sort of, you know, evidence from the literature about the effects of those sorts of options to increase carbon in soils. But just to kind of think before we sort of dive into, you know, all of these techniques that we might use, is to sort of consider, you know, how long it takes for that change to happen. So, you know, obviously, if you put some manure on and measure it the next day, of course, you're going to see an increase. But what we're looking for is that increase in that stock. So in your savings account, so what is really being sequestered and held in the soil long term, not this very sort of fast cycling carbon that is being, you know, utilized by the microbes, but that has the capacity to be sort of locked away in the soil. And there was some work done some time ago that identified actually that, you know, if you start to implement a particular practice, so this is based on an experimental site where they'd added different concentrations of organic matter. So that's along the bottom axis there. And they were seeing that it wasn't a straight line. So you would have thought that by adding more organic matter, you would see a similar increase in the organic carbon content in the soil. So that's on the y-axis there. But actually what they were seeing, is this based on experimental data as the dots, and then they fitted this model to it, that actually was seeing this kind of equilibrium or plateau. So even though you were adding more carbon, probably what was happening was your microbial activity was increasing, that population was expanding and utilizing that carbon source. But the effect then that it was cycling that carbon more rapidly. So a lot of it was actually being released through respiration as carbon dioxide and not being locked up in the soil in that kind of saving account. So that's one thing to remember if you're changing a practice, is that over time, as you maintain that practice, you will reach a kind of equilibrium in terms of the carbon content. And I'll show a graph that sort of illustrates that is after this one. So just to go back to those sort of options that I showed you before. So one is for those where we've got high stock of carbon. So think back to those brown blobs on the map that I showed you, is to actually try to keep those in the ground. And, you know, someone mentioned drainage earlier. The picture on the left actually is not anywhere near the southwest. This is over in the Fen in East Anglia, actually on some lowland peats, where there's been serious wastage and oxidation of those peats by many metres due to draining for agriculture. Again, some upland areas have also been drained for things, you know, like grouse shooting and stuff like this. So it's thinking about options then to re-wet some of these soils. The organic matter is preserved where there is little oxygen, and there's little oxygen because basically the profile is full of water, so that organic matter can accumulate. And then also just to touch on the final, so the middle one is an upland peat. The other picture on the right hand side are these organomineral soils. So this is a podsol, Tim had some much better pictures than I did. And you can see there's still a significant amount of organic matter, so that dark colour in the surface, even in these sort of upland fringe soils as well. So making sure that those conditions, so reducing drainage, reducing also liming and things like this in these sorts of soils, because it's the acidic nature of these that actually enhances then the accumulation of the organic matter in those soils. Okay, so what other options do we have then, maybe to increase, organic matter? So we did, land use conversion is the big thing. This is not always possible, as we've indicated before. We still need to grow food, but there's some compelling evidence that also demonstrates this kind of equilibrium or saturation level, and this is from some experimental work at Rothamsted Research. So I'll just sort of walk you through. So on the left-hand side, so we've got time along the bottom. So these experiments were started in the late 1940s, and there's data until 2010. So over 60 or 70 years of data. And the one on the top here started off as a grassland, and there was a site that remained in this is permanent pasture over that time period, a slight increase. And in one site, that permanent pasture was converted to arable, and you can see that decline over that time period, fairly rapid in the first 20 to 30 years, but it actually reaches an equilibrium towards the end of that time period. And similarly, where you had an arable site on the same soil where it remained arable, you're starting to see a slight decline there as well. But where that arable site was converted to permanent pasture, you see the build-up of that organic matter. So that land use change is happening quite rapidly. So if you think about when you're monitoring your carbon change over that time period, you're going to see a trend in the right direction over 20 to 30 years, and after that point in time, that system starts to equilibrate under the new land use, and you're not able then to increase that carbon any further. We've talked about adding more things. So if you think about that cycle, more often than not in many of our cropping systems and grassland systems, we're taking away a lot of that input through harvesting or through grazing. So adding that back in, either through organic amendments or in-field inputs. So York had some really nice demonstration of some intercrops there with the rye, with the maize, adding those residues. It's really important to have that soil cover over that the whole rotation. So you're adding also exudates and carbon in through the roots of the plants as well, and also stimulating that microbial activity. Other things that you might want to think about is obviously adding things like manures, but are there enough to go round? Do you have access to livestock for that? And again, if you think about this plateau, you need to continue to add that carbon source, or it will start to decrease again. So even though once it reaches an equilibrium, you still need to maintain that addition to maintain that equilibrium carbon content. We talked a little bit about it, goes in any detail, but again, other things to kind of mitigate kind of the loss of the carbon. So start to reduce cultivations, incorporating kind of mixed farming again. So thinking about this evidence of incorporating ley, grassland into arable rotations as well, that's shown to increase carbon contents in soils too. Thinking about grassland, thinking about changing the species diversity of the sward as well, introducing things like legumes into those grasses. And Becky also talked about this at the beginning. So again, just to remind you again about grazing management. So using things like sort of graze and rest, cell grazing, these sorts of things have been shown to give the grass time to recover and start to input carbon back into that system again. One through reducing the amount of vegetation that's taken off, but also the roots are a really important source of that carbon as well. And they also feed the microbiology, which is also another source of organic matter in soils too. Yeah, just to show some data, this is just a review paper looking at these sorts of land management practices to increase carbon in grasslands. So this is looking at how much carbon was sequestered by implementing these different practices per hectare per year. And this is over quite a, this is not in the southwest, this was a global study. So again, we need to think about the, the evidence or the application of this at a local level. So is it going to work on your farm for your soil types under your farming conditions and the climatic conditions? But generally, where there were quite a lot of studies, there were evidence then that, well, increased nitrogen fertilisation can actually also increase carbon. Improves grazing practices through these sorts of graze and rest approaches again also increase the sequestration rate. Some of these practices here have quite low numbers, so there's probably quite a lot of uncertainty on the actual efficacy of these, until we get more data, I guess. And then, they also looked at land use conversion from arable to grassland, and that also demonstrated, like I showed you in the last slide, that you can increase the carbon sequestration rate. So grasslands are very good at storing carbon. Yeah, so I'd just like to just to finish really on a couple of takeaways really. So just to remind ourselves again and to reiterate that soil organic carbon, soil organic matter has many co-benefits to soil health. So we think about the biology, the nutrient cycling, water quantity and quality, and now we're kind of in a space where there's an opportunity to enhance on that excellent sort of national database that we have, to start to think about adding granularity to that, to map and monitor at a local level at a farm scale. And it's really exciting to see that all of this is happening already through the talks that were done through the morning, that people are starting to dig to just observe their soils, but also to start sampling and to benchmark themselves to see what things work best for their particular farming system. And we can see there's various opportunities there, to increase then organic matter and organic carbon in soils, but just to be mindful that that will reach a saturation under that new land management regime or land use, and that needs to be maintained for that equilibrium to be maintained. Yeah, and I think we've touched upon this before about making sure that we're applying the right technique in the right place. So taking into account that local condition, talking also to farmers and landowners about potential barriers to adopting these, whether they're working, whether we can sort of monitor then the direction of travel after implementation of these particular techniques. Okay, so that's it from me.
Thank you, Jacqueline. That was really good, and good to have a kind of an overview of everything that's happening, and that slightly broader feel to it, and understand some of those the scientific elements to it as well. Have a look in the chat. There's a lot of conversations, and there were not too many questions, and I'm aware we're quite a bit over time. So
yeah, that's fine.
But that was mostly my fault for going on a bit in my area. So so that's really good, and thanks for that. So actually, I've just got a quick question from John. Perhaps we'll do that quickly, and then we'll kind of wrap up. So so John's saying, Jacqueline, how best to balance the benefits of grassland in terms of storing carbon compared to the methane challenges associated with bovine farming or cattle? I suppose that's quite technical.
It is, that's tricky. Well, so livestock isn't my speciality, I'm afraid, but I think there's been a lot of work about looking at species in terms of the diet for the cattle themselves. So actually trying to think about other ways of reducing methane emissions from the livestock through changing some of the feedstocks or the species diversity in some of the swards. So there is a trade-off there through thinking about other types of greenhouse gases. So we've focused on CO2 and carbon, but yeah, methane, also nitrous oxides as well. So again, thinking about some of those techniques that were demonstrated where, you know, fertilization obviously had a positive benefit on the storage of carbon, but again, you know, you've got to balance that against other potential other, you know, environmental outcomes through nitrates and surface waters and things like this. So yeah, it's not an easy, you know, you have to think of it, the system, you know, it is a complex system where one intervention might cause you know, an issue in another place in the catchment, or yeah.
Great. Okay. Well, thanks for that. Leslie, I think it's been really good to get those mix of talks today and some of the practical elements, some of the real interest in the kind of the soil type and habitats, and kind of the wide overview and mapping. You see there's kind of a lot going on in the minute, especially with this kind of trying to assess soil carbon and get an understanding, get a baseline, and something we're trying to work on. So obviously we're going to try and run a bit of a field event later in the spring, early summer, which would be good, and I'll send out invites for that when we've got a date. But again, just main thing is that yeah, we very much want Devon Cornwall Soils Alliance to kind of continue as an entity, and kind of, you know, beyond this WEG funded stage. So we'll be looking for it to kind of join a bit on some of the projects going on that are happening and benefit from those. And then, yeah, otherwise, any other sort of questions, if you may have in particular, you can send across to me. I'll put my email in the chat. But otherwise, I'll let you get on and enjoy your days, rest of your day, and go from there. And thanks to everyone else for attending. And yeah, I'm sure you'll have some overdue lunch now, I expect. I'm quite pleased to make a start on that. So I'll say thanks to all. And anyone else wants to get in touch, just give me a call directly or shout. And I'll say over and out. Cheers all.
Cheers.